charge at 6 o'clock, at 7 around to 200 and something people. So you can see the pattern. It is something similar to our load only. So you can see the pattern of charging is something like this. Okay, again, after this 4 o'clock to this, more people are charging. So now, like when we are, when we want to shift the load or to off-peak periods, and we have to bring some tariff plans so that these loads the peak can be cut and it can be taken out. So this is only the electric vehicle load I'm saying. So you can see here around 1,600, like 1,000, around 1,700 people are charging during this 17 hour. Okay, the 17 hour, 16 for almost 5 o'clock or something, a very peak load is coming here. So such data can also be taken. This is a weekend. So weekend pattern, you can see it's very difficult, different when people are at home. Mainly, if you see in the early mornings, might be they are not charging it, and during the afternoon hours, you can see a good, very good charging pattern, and then it goes decreasing. It's just like a mountain here. Okay, normally distributed this one. So might be these datas may help us in many studies which we can do. So this is one thing. This is with respect to the hour, how many vehicles are charging, and based on the duration, how many people are charging for a longer time, how many. So here you can see some people, like around 500 people have charged only for 10 minutes interval. Okay, and around 20 people have charged for 1,000 1,000 number of people have charged for 20 minutes, and maximum from this you can see 120 minutes, the sense 2 hours. Okay, 60 plus 60, yeah, 120 in the sense 2 hours many people have charged. So this also gives an idea of how the what is the charging pattern and how many people are charging at an instance. So such data can be obtained. So this one is the thing, during weekdays, this is the charging pattern. People are putting it for 2 hours. Let us see this for the weekends. Yeah, in weekends also, if you see, the maximum is again 120 only, 120. So on an average, every day people might charge for almost 2 hours, and that 2 hours also mostly they prefer during 5 o'clock in the evening. So this is the pattern of Uppsala city. Okay, and might be again with region to region this may change. So this also will be a very important data that is required for our the EB department, and for for load scheduling and many other cases. So such studies can also be taken up when these are all data driven studies. So we have to so now it's time for us to understand what type of data are required for us in future. And when these electric vehicles, now a lot of electric vehicles are sold out in India also. So we have to identify in which are the areas many electric vehicles are used, and we have to try to extract their data so that such data will be helpful for us. So now we have to plan out like what type of researches are possible and what are the data we require for it. Okay, so because thinking that yeah, let electric vehicle come, then we can take decision, that's not possible. So now we have to think of like what different types. So for power quality studies, for such data, so for such studies, it is not required that you have to take the samples at very high 500 kilohertz sampling and all is not required. Here, these data were taken every 15 minutes interval. Okay, some data are there which were taken in 30 minutes interval also. So this is taken for the whole year. So such data can be taken up, and some of these studies, if you see for power quality studies and all, again depending on what type of research you are going to do. For only for lower order harmonics, you can go for less number of samples, or interharmonics, or whether supraharmonics you want to determine accordingly, or like if you're going to transients or other studies, voltage dip and all, then accordingly you have to just plan out. For such voltage dip and all also, it is not necessary that you have to take very 500 kilohertz sample. So accordingly you have to decide like what type of data you require for analyzing. So now it's time for us to look into these power quality analyzers and try to collect data. So that's also a very important thing in the initial stage. And apart from this, it can go for researchers like designing different topologies of these
Excuse
different.
me, madam.
Yes, sir.
Madam, I think it is not recording, madam. Session is not recording, madam.
Oh, session is, yeah. Like Gopal, are you there? Gopal? Gopal? Yes, yeah, please start the recording. Now anyway stopped it when sir will be starting now. So Kartikesh sir, have you joined? Kartikesh sir, are you there?
Yes, ma'am. Am I
Yeah,
audible?
yes, sir, you're
Good
audible.
morning, ma'am.
Good morning, good morning. So, like Gopal, please record the session when it starts. So, I think I was just giving them like because I knew you were joining little late, so I was just trying to share one of the research we did there for collecting data
Okay,
on
okay,
seeing the patterns. That was a different type of research, but I thought like
okay.
when I got 15 minutes, I shared it. And now,
Yeah.
first, I would like to take the opportunity to introduce the expert for today. So, I'm just taking a minute. And for today and tomorrow, it is fully with us is Mr. Kartikesh Kumar Jha. So he is an technical specialist in ANSYS, low frequency and EV at ARK Info Solutions. So ARK is the supporting partner of ANSYS in India. So they are also supporting us in all ways. Like we have already ANSYS software for Maxwell, and now we are in the process of purchasing these EV based software also, which will be helpful for our researchers here. And actually, talking about Kartikesh sir, he has an good experience in the field of teaching. Also, he was assistant professor in the university. I don't remember actually. These some universities in Jharkhand, Central University in Jharkhand, and he was also the junior research fellow at NIT Patna during 2017 to 2020, and there he was working on a DST project, design and development of low cost BLDC motor drive for solar PV irrigation system. And after that he joined ARK, and he is a specialist in this answers mainly for electric vehicle also. So sir had already delivered some lectures for us, and he has promised that he will give you some hands-on experience also. And sir, for the thing, many participants were contacting me for the 32 bit version, because many of them in one of the colleges their system itself was 32. So I had asked them to their faculty laptops they can use, and some participants also individually they had only 32 bit. So is there any solution for you? I asked Tushar sir, but he was telling it's difficult. But that's what in case, and if at your end, if you have anything, if you can give some solutions to them, that will also be better. And now I hand over the session to you, sir, and you can take over.
Okay, thank you, ma'am. So, so today we will basically look into first how we can. ANSYS will basically help you in design and development of electric vehicle throughout the simulation, like from the battery to motor, and then we will go one by one how you can utilize Maxwell by using your student version if you download that. But for the student version or the higher version of ANSYS, now we basically required 64-bit system. So that is the problem. So I will also connect with my team and I will discuss this. Okay. And then if any solution or lower version that will be feasible or download will be possible, so then I will let you know, see how we can proceed, if we can go for 32-bit or not. Okay, so let me share my screen. If my screen is visible, please let me know.
No, sir, not visible.
Right now I am just sharing. Just wait. Give me a second. Is my screen visible now?
Not yet, Kartikesh. Yes, now it is visible.
No.
Okay. So first we will go for introduction and the design and development, and then we will basically proceed for practice in 2D and 3D. And Tushar sir, can we do something for the 32-bit system if they some participant basically having a laptop or the
I
system?
heard I heard it what ma'am was saying. Even I
Okay.
intimated ma'am also that
Yeah,
ANSYS
yes.
is
Okay.
not supporting on 32-bit software.
That is
So
the
I have reconfirmed it with ANSYS also.
okay.
So that is the mandate thing that 64-bit operating system is been required, and that is of Windows 10.
Yeah, so I too intimated those people who have asked me. It's not possible, but yeah, but might be there. That is the thing. Then you also
So
had 32-bit before, I think, but now might be the new features will not be supported. So it's better.
no, no, ma'am.
Hmm.
Now the latest version will not even installed on 32-bit.
32. Okay, okay. So that's
It will give
problem.
an error while installing it itself.
Yeah, yeah. So no
But
problem
backend,
for next.
but
Well,
backend, we are trying to
for us,
resolve it by providing you the license. If it is possible that tomorrow everyone can do the hands-on.
Okay.
So
Yeah,
we are
yeah.
trying from our side. Let's see if it works. Then it will be good for all the participants.
Yeah, yeah. Yes, sir.
Okay. Kartikesh, please
okay,
continue.
so yeah. So ANSYS will basically provides you a pervasive simulation. So this means we basically do continuous simulation because we are basically doing research to get something, get some result that is not visualized. You are basically thinking. So ideation phase is very important to lock your idea, so it will basically give you, and the more time will be gone in that, and if idea will come to the mind and then you will design for the hardware design and development, you are going to that part. But some problem like heating issue, some problem like the size of the machine, and the other problem will be happen, so then we have to go for redesigning, and on our 3 month to 6 month time will be wasted. So first we basically lock our ideation time, and we can do the simulation research and result. After getting the result, we are assured if we are going towards hardware design and development, or if I will do this type of research or change the parameters or the change the other things, so that we can easily able to achieve the certain result which we desired. We can also, this will basically reduce your overall development time of your cycle, development cycle of the whole process. Like if you are designing your EV, this means you have to think about battery, you have to think about power electronics component. Then in the power electronics divided selection, if you go in deep detail, it will give like which switch I have to select, like which diode I have to select for my simulation or for my hardware design, which diode will be capable of that much capacity of the current voltage or with stand capacity. So all designing and development, and then the switching losses and MOSFET, IGBT, which one to select. So other components like which motor I will select and which topology I will do and select for my design and development, which like right now people are interested with the axial flux motor. They basically want to design axial flux because the size they want to reduce, the copper present and the magnet present inside the machine, they basically want to reduce that. Like in the manufacturing part you can see, so they are we are able to, by designing and optimizing all process, we are able to reduce the overall weight of the electric vehicle by 25%. And operational also we can like if you are creating a circuit and one hotspot, due to that hotspot or the heating point present in the machine will basically uh, reduce your overall performance of the machine, so that we can rating of the machine can be increased, in production time will be reduced. So ANSYS will basically provides you the best of the breed simulation across, like all the physics can be present in the single platform, like material information that is provided by Granta material. And in that material information, we can do the simulation of fluid, structural, electromagnetic, semiconductor power, embedded software and optical things. So we can do all the simulation, and then the connectivity of all the major physics with each other is very, very smooth in ANSYS. Oh, this is the our some companies. So they are basically utilizing like Pfizer, SKF, ABB, CAT, so Airbus, Volvo. So these are the companies we are leveraging our product ANSYS, and these are the partial list of the academics. So they are also using it. So now we will go for how ANSYS will help you in their design and development of the vehicle. Now you can see ANSYS will basically provides you a virtual lab that will be accessed anytime, anywhere, and at any scale. Like you want to change your motor from 3 HP to 5 HP, that also you can do. And sometimes you want to do the fluid, like you are riding in in your car, and you basically want to calculate the drag, air drag is there or not, and you want to calculate if I will change the size or weight of my vehicle, then what was the behavior of the overall performance, what was the duty cycle which I will put that on the machine, so that to that particular road condition, that will be feasible for me or not. So these we all the analysis we can do. And now we will go one by the battery and the battery management system. Then we will go for electric machine, then we will go for power electronics, and then we will switch to powertrain system integration. Means we are combining battery, electrical machine, and the power electronics in a same platform, and then we will analyze noise and vibration, system integration, embedded functional safety. So these things we will see one by one, and we will also design one motor in the after like today or tomorrow session. We will also go for that. We will also see how transformer is designed and how we can do the electromagnetic calculation. So these things we will also check. Battery and the battery management system. So what was the main goal in design and development of the battery? So the main goal is the power density of the battery, charging and discharging time and the cycle, and overall operating life of the battery. So these are the major requirement when we are basically selecting our topology of the battery. And after that it will come like EMI, EMC safety or industrial standard is there if I have designed a battery, but that is not up to the standard, government standard, then we can't do go for the production. So that also standard should be meet. So one first we have to how we can proceed that and how we can achieve our goal. So for achieving our goal, we basically have to do the sales and the electrode performance. We have to do the thermal and mechanical analysis. We have to do the EMI, EMC if the present in the battery. So for that, we have to design a good filter, celting, and the component selection is also important. We have to do the software and the system team is there. So the battery management system is required. Like you have designed the battery, but battery management like SOCs and the other things related to health of the battery information will be from the software and the software team. So when you start designing your cell and the electrode, the result or the you can say the mace of the surfer will look like this, like the macing in the cell which we have designed, and this is the accurate. You can see the 3D model result is there. So one paper is already citing this. The 3D model predict the global discharge characteristics that are consistent with the experimental result they are getting. So they are able to predict the and different discharge rate. You can easily able to select the particle size of your calculation. You can also after designing you can go for minimizing the weight volume ratio for optimized pack designing. So first we are creating the cell. After creating the cell, we basically have to create a number of cell in the series and parallel form. We have to create end-to-end plate for the macing, and then we will go for the module of the and then do the temperature and the current contour analysis. So we can easily able to do that. Like first we have to create a cell, then make it in the form of core, then model, and then do the analysis, and then we can check any part we are getting the hotspot, and how we can like early detection and mitigation of that part will be important. Now our battery pack and the module is ready. We have to provide heat sink for the module. So for designing the heat sink, now we can see the temperature. This part is getting affected when we are basically not providing a good thermal protection, or heat sink we are not providing, or we are not using heat sink right now. So then the temperature, the level of the temperature will be such high. So how we can design our a lot of things like the blast of the battery, or the sometimes at the charging is happening to the battery, and the battery get fire. So how these are the main problems you can say in EVs. Basic problem we can like charging will be happen, and due to the overcharging the battery explode. So these things how we can mitigate, and by using the good battery management system we can control, we can cut off the supply. Yeah, after certain level of like thermal sensor we can attach with the battery, and then we can check the level of the temperature. Good thermistor will be attached with that, and then we can sense that level of the temperature, and then we can cut off the whole supply, and then we can reduce that impact. We will reduce, or we can avoid that impact. Now this is the battery designed with the air cooled system. In ANSYS, what we will basically do, we will first create the battery, and then for the faster getting the simulation result, we will do the reduce order modeling ROM. So in that ROM, what we will do, we will basically convert our whole design into an electrical circuit. So in that electrical circuit, we can easily able to get the result very fast. If you change some design parameter in the battery, then we will like you can get the different value of resistance, capacitance, and the other things that is connected to the battery. So that redesigning, and then we can do the analysis of that. So we can easily so this will give you a result within a second, because it is reduced in a circuit form. So it will not take much time as a 3D to get the result. So, and if you change material or the other things, the value of the resistance and capacitance is also changing. So we can, or if you want your system capabilities more, so then we can do the thermal modeling directly by using the ANSYS Fluent. So there we can do that. And we can also provide a liquid cooling to our system, like our battery pack thermal management is there. So in that I will also do the liquid cooling. We can also do, like we will create a battery, and then we will provide certain liquid, and then we can do the same ANSYS Fluent, and the twin builder is required, and then we can calculate the thermal behavior and the SOCs of our battery. Now we have designed our battery, and that battery is working fine with the battery management system. Now we want to check if some crash or other things happen, how my battery will behave. So we will do the nail penetration analysis in that. Like you can see, we are doing the nail penetration analysis here. So in that we will check the impact due to this nail penetration, or if any other vibration or something thermal runaway, how we can, what was the effect it will get. So that we can easily able to check, and we will easily able to remove it at my early design state. Now battery should be battery should be in compliance with the EMI EMC certification. So for that only, what we will do, we will basically create a battery as a circuit, and then connect it with the whole device. Like you can see, DC cable is there, in full inverter part is there, and the AC machine. And now we are connecting, and then we can check the behavior of the battery. So we can easily able to detect our, we can do by using the HFSS, we can do the EMI-EMC analysis of my battery, and after that we can go for certification, because the EMI-EMC is the major effect, like your whole system is working but it will not pass the EMI-EMC, then you cannot go for commercialization of your project. So the EMI-EMC, the effect should be a very important factor finalizing your machine. Like if you are using your electric vehicle, and when mobile is ringing or someone call you, and it will affect the overall performance of the machine, so that should not be happen. Even your machine should like all your electric vehicle should not affect others, so that also we have to do. And then we have to like designing. Now we basically want to make our system to be more familiar with the peoples that are using our system. Like we can easily able to see the SOC charge state of my battery, and if possible we will also code something that will give me due to this that much charge is available to my battery, up to what extent it will go. So that information, like model based design, we can also do. We can also do the check the safety standard that is present outside, like ISO 26262, AutoSAR, and the others like other safety essence like FUSA. So these things we can have to add our designing, and we also have to check if our design which we are designing is meeting the safety standard or the driving standard or not. So that also we can do this. And this is the validation of real time. Like you can see here we have the uh, pack CFD, and we have the sale HPC. This is the reduced part result, and then that information we are sending into the module of the pack thermal ROM or the module or pack ECM, and then we are transferring that information to battery management control. Now you can see here we have the maximum allowed current range is at red part is getting above the maximum allowed. So this is the transient dynamic analysis. So in that we can easily able to see how up to what extent or up to what maximum allowed current we have given to us, and then we are able to do that or not. So that current ratio by time, that we can easily able to do the analysis with the battery management system is affected or not. Now for the integration part, we basically have to check the machine. So first designed, you can see the internal permanent magnet motor, IPM motor is there, and the next is the efficiency map or torque versus speed characteristics is there. So we are basically using that with the overall system, and then we have to check the, this is the power and the power electronics cables and the machine. So and then we have to check the trade-off studies and the optimization. We have to make certain things like if that much power is there, up to like what extent it will, we can get the result from the battery, or up to what extent we can utilize our battery. Like right now how we can design our battery for the only for the machine, and the other battery auxiliary battery design and development for my other things. Like sometimes people are basically adding some charging of the mobile phone using your battery, some charging, and the other like music horn for the, and also the auxiliary battery, or I will keep that same battery for the overall system. So that we can also do. So this is the battery capabilities and applications, and these are the ANSYS product mapping is there. So for this type of work or capability or the application, we have to select the ANSYS product like that. So this is the whole mapping of the ANSYS product matrix is there. So like we want a system integration, then we have to go for twin builder, then we have the battery management system, so then we have battery controlled. We have the EMI-EMC due to switching, so that required a certain ANSYS fluent for designing a cell. So these are the list of products and these are the applications. Now our batteries design, we will go for electrical machine design and development. So in that electrical machine, like the battery, we also required our improved power density, energy efficient, and the operational of the battery should be meet our industrial standard and the safety. So for that we required an electrical machine design team to achieve that goal. We required thermal and CFD team, mechanical team, and the software and control team to create a controller for my machine. So these are the team that is required for the electrical machine design and development. And we will go one by one. First, we have to select our concept, or you can say the topology of the machine, which machine I have to go with for that particular torque, power, and size of the machine. So which one I have to go with, or which one I have to select. So first, like I will go with someone will interested in induction motor, someone is interested in BLDC motor. Now we are people are interested in axial flux motor design and development. So according to our use, or according to our mm, you can say the cost of the product, we have to go for selection of the material, and with that cost how we can improve our overall design. So that is the main thing we required from a design engineer. So that like if you select the open the Maxwell or MotorCAD, you have to do the electromagnetic analysis of the machine, you have to do the thermal analysis like cooling of the machine, you have to do the stress and the displacement of the rotor in the mechanical, we have to do the efficiency mapping of my machine. So that analysis we have to do, so that we can easily able to do by using the MotorCAD, or we can do the FEA analysis of the electrical machine like flux density plot, and we can after designing connect the whole process with the ANSYS OptiSlag. So there we can do the optimization of the machine. So now you have selected the machine, but machine is consistent with the material information, how you are designing stator and the rotor, and the which material you are basically using it. Like sometimes you want for the cost reduction, you want like copper, or the other material should be less, or the way cost of the material, am I able to reduce? Like you can say in the medicine also we will basically think about like normal medicine, generic medicine, but replace the same thing, same material characteristics which is required by us. So that material information, if I will get at the cheaper rate, so that we will use it for our application, but the torque, power, and packaging requirement should be the same. So that ANSYS is having the granta material. So from there, lot of material information are there. So from there, you can easily able to do the analysis. Or if some material is there, then we have to do the edit material information. And there we can, like NITTTR is changing one material, or going a research is going on in one material. So they will named it as a NITTTR material one, and then we can put the information and we can do the overall analysis like that only. And this is the efficiency map or the torque speed characteristics. In that we can see blue dots are there, so that are the driving cycle which we are putting for that machine design. Like you have designed the machine and your efficiency map is created. In that efficiency map, what are the driving cycle is required, so that we are putting it here. And you can easily see the Magna Electronics, they are basically using, and they are confirming that they are getting the experimental and simulation result same. So you can believe in the uh, answer. So that will basically like you what you will design, and you will get the efficiency map, you will get the similar result by in the hardware also. And then we can do, like, our machine is designed, now we have to do the thermal analysis of the motor. So in that motor, we first, according to that EM losses, electromagnetic losses, you will able to predict the thermal behavior, or from the thermal behavior also you can easily able to get the mechanical losses. So this both way communication is possible, like magnet losses, core loss, copper loss, and the mapping losses is there, and the oil. And if we will do, or we will design our machine, or cooling is able, we are predict the cooling temperature, cooling of the machine. So then we oil cool spray or any other method, or other component we will use. So that will basically increase the efficiency or rating of my machine. Now your machine is designed and you are riding in an electric vehicle. So but when you are sitting in as a customer in that, and you are facing some vibration and the other noises are there, you are not comfortable with that noise or the sound present in the, because EVs are basically very silent, and if some other noise will come to you, so it will basically not comfortable for the passenger that is sitting in the electric vehicle. So that also we have to do the noise, vibration, and the harness and the structural integrity analysis in the Maxwell. So we have to calculate the electromagnetic forces and the other things, and then we have to do the multi-body dynamic. Then we have to go for harmonics and the sound quality prediction. And then we, by using that, you can see the one waterfall diagram will be created. So the waterfall diagram, from that we will able to get red hot parts in that, so that how we can remove, and how we can, like, how we can remove that. For according to our applications, we can do by using the this waterfall diagram. We can also optimize our drive line performance and noise control. We can also do by using the acoustic simulation based on surface velocity. So now our motor is designed. We have the multi-objective to be specified, like packaging, efficiency, weight, durability, noise and vibration, and the cost of the machine. So these are the parameter and the performance you can say. So ANSYS will basically gives you the multi-objective, multi-physics traction motor optimization. We can do it here. So one is a tool like space claim is connected with the opti slang, and can be connected with the mechanical stress and stress analysis, can be connected with the Maxwell for the efficiency mapping, can be connected with the thermal fluent for checking the temperature. So one page can be easily connected to the other tool with the to do the analysis, and get the better efficiency, get the better weight reductions, and the less size of the magnet, and the less quieter machine we can design. And now your machine is designed, and we are basically creating a controlling strategy for our designed machine, like connecting it with the inverter. So how the behavior will be done, so that we can also do. These are the applications and the capability and the answer product. For that particular applications, we can do like cooling, we required ANSYS mechanical, fluent, and the ANSYS OptiSlang Granta material information is also required. So according to our application, we have to select the products. Now our machine and our battery is designed. We basically have to connect these two by using power electronics devices. So here we have to think about our goals, like we basically required a multidisciplinary designed workflow for this power density, lifetime of the switch, what was the capability, like over voltage, noise, and thermal degrade, reducing losses. So these things we have to check before selecting the material, like electrical. So for that only we required electrical team, we required mechanical team, we required software team for to do the embedded design and the testing, and then the electromagnetic and the thermal team to do the magnetic analysis, thermal management of the or selection of the component and do the thermal performance. So in ANSYS, we can do the like multi-domain circuit, and the system simulation is also possible. Like ANSYS 3D physics can be connected with the co-simulation of the other 3D products. Also, the communication is possible with the Simulink, GT. So that also we can do. Like for example, you can see here we have a regulated flyback converter. So first we can design the 3D model of our flyback converter, and that designed 3D flyback converter is connected with the power electronics devices, switching devices, and the other things. So that we can easily able to do, like design inverter or design a switch in 3D and then connect it and check the behavior of that switch with the devices, other devices connection. And now we can see the magnetic analysis. We can like temperature limit of the inductor and transformer, leakage, overprotection, and what are the parasitic effect. Like your whole machine is designed, and then the IGBT. So this is the IGBT which we have selected by using the reduced order modeling. We can account for the component interaction with the other, like whole machine is there, machine PMSM is connected, speed control we are doing using the space vector, and then we required a component, like but we want to check we have according to our data sheet or according to our information, like up to the what extent our temperature it will sustain or not, so that it will create a hotspot or not. So we basically have to create our according to our data sheet or according to our requirement the switch we can design and develop, and that switch we can connect, and we can see the skin and proximity effect. We can do the co-simulation with that. Now, like we have selected our IGBTs and we are getting the hotspot in that part. So we can, by using the thermal analysis of the switch, we can easily able to get the results like hotspot and the thermal prediction we can do. So these are the parameter we have to feed in the IGBT, and this according to that we will get the outputs. These are, and then we have to do the embedded control we have to do by using a scared suit. We can do the embedded, we have to write this code in that, and according to that code we will get the information, like you want to control or you have to provide some clock information to the switch. At particular time the switch will be on, and that particular times the switch should be off, so that information also we can put it here. So this will basically give you the flexible and scalable model based system we can design. So this will the benefit you will get, like you are able to reduce the overall development time and the cost of the design and development of embedded hardware. And it also provides you the EMC certification. It will also create according to other EMI-EMC like CRIS, CIS power spectrum. You will get the like labels like 15, 16, and 25. You can create the license circuit for our your design, and you can connect it with the, and then we this will basically the main is there, you can easily able to get the weak point in that, and then we can this will overall like make you more familiar or make reduce the time and the cost of the whole design and development. You will get it, like number of cycle to do the EMI-EMC will be reduced. And you can also do the PCB reliability of the machine in that, like you can do the lifetime prediction of the design machine. You can say you have a PCB with you can do the thermal analysis, you can easily able to predict the life of the machine. You can also select the material and the component libraries connected with that. So this will make overall system will be less costlier, and this will like number of iteration reiteration in going to the hardware will be very reduced by using this. These are the capabilities, and ANSYS products are there, so you can connect like power electronics. I required a simplorer, I required a twin builder to connect it with the ANSYS circuit is also required. So for particular application you require a required a particular ANSYS product. But you can see we have the more products connected with each other. So the ANSYS product, maximum products are already covered by using the max motor design, the and you can say the battery design. So maximum products are similarly same. Now what we have to do, our design of machine, our design of the battery, and our power electronics design all are done. Now we basically want our whole system to be run fine in a systematic manner. So main goal of our EVs is to provide me the or others to the like performance, safety, and the cost effective. Like if I have to buy the EVs, when I will go there, I will basically ask for what was the range of my vehicle and what was the weight of the EV, and up to what was the charging time for my EVs. So these things will work properly. Like your battery is working very fine with the other component, but when you are connected with the whole EV system, you are not getting good results. So if the situation will be like that, your EV will be not in use. So for that we have to do the system integration and do the analysis for that, like component validation, like component level validation we have to do by using the component library. Then we have to do the co-simulation between one tool with the other tool, and then do the system integration. We have to do the power train modeling we have to do, and the for full model integration also we have to do. We have to do the third party ecosystem is also required sometime for designing the controller, MATLAB simulating. So that also we can do it here, and then our whole analysis of the EV I can go up to that extent which where I can think I can design in ANSYS. So this will like you can see we have the library inter-exchangeable component we can do. So the bus bars, like cables and the bus bar application. So we can also design a cable in ANSYS and then do the analysis. So cables we can design, bus bars also we can design and connect. Means up to what extent we are looking at the hardware design, that we can easily able to achieve it. Now this is the multi-fidelity models and the multi-level simulation is there. Okay, just give me a time. I will connect charger. So we have the multi-fidelity model and multi-labels libraries are available to us. By using that we can do the V and V analysis. So value and the validation analysis we can easily able to do. We have the result in the sometime we have the result in the form of function. Sometime we have the result in terms of design of experiment EOE, and then and sometime we have the graph. So all information can be used to do the value addition or validation of my design circuit. So first we have to do the specification and requirement, then we have to go to architectural design, then subsystem design, then do the optimization, and then we have to check component integration and verification. If not done, then we have to redesign the subsystem. If that will be okay, then we have to go for system level integration and validation. If any problem will happen, then we have to then go for redesigning of our system functions. So then we have to finally go for system validation. And this is the look of the system integration part, like power source. Now we can also use the fuel cell and the other cells also we can design, and then the power electronics inverters, cables, and the machine is connected with the overall embedded control also we are providing it. Like sometimes you want your vehicle to be run as automatic vehicle, people are going to the driverless design of the machine. So that we also required a virtual information or the all image detection techniques we have to feed in the system, so that by car will detect the image that is coming, and according to that it will decide I have to go slow, I have to go fast. So this information of the coding is also required to cover complete design and going for automation part. And this is the embedded. By using the embedded, we can easily able to do the like certified embedded software, and it will overall, you can say, the more insight about the component and make you the more intelligent decision to design your control. So this is the V and V workflow. And then this is the functional safety according to ISO 26262 or the others. You can also review your design, and the automated document will be generated, so that can be used for getting the time to market. Like you have designed and you have done this analysis, so the time to going to the market will be reduced. Overall additional cost or the high performance complexity will be little bit reduced. You can say the complexity of going to market will be also reduced. And these are the applications, and according to that we have the products line. And this is the product design and validation, like component, battery, power electronics, embedded, mechanical, bus bars, and the electrical machine, and then do the data validation, battery system connection. So these are the, you can see, the block diagram of your EV. And this is the products, and according to that, this is the overall ANSYS product library and the mapping. And these are the some research area for the electrical machine, battery packs, power electronics, system integration. And these are the certain opportunities for the student to get involved in the design and development of EV. And they can also search, like there are many like you can say there are many posts related to design and development of the electric motor or induction motor. You can also see for the Havels, they are basically going for induction motor design and development. And the other companies are also there, so they are also looking for the design and development for the battery. And there are many you can say the fast growing right now is the battery management system design and development applications. Jobs are highest in the market. You can also search that in that Naukri portal or any other. So their design and development of your embedded and the other component like EMI-EMC analysis. If someone is doing EMI-EMC analysis of the component, so that is also a hard job, you can say. These are the certain opportunities like scientific research, design and development, manufacturing, maintenance, sales and support. And these are the some products like a company, Lucid Motor. They are basically using ANSYS design, and they are effectively predicting the their thermal performance of the engine
Sir, are you speaking? I couldn't hear. Is it my end problem or everyone is not able to listen to you?
Yes, that is not audible.
Yeah, yeah, yeah. Kartikesh sir, can you hear us? Kartikesh sir, we couldn't hear you. Like you're speaking that I could see, but we couldn't hear you. There may be some technical problem. He may join, so let us wait.
Yeah, am I audible?
Yes, sir, it is audible. It's audible.
Okay, so I think when I lost the connection, at that time I thought nobody is asking question. Hello,
Yes, sir.
ma'am. When my connection is lost,
Last, sir, when you were showing the car picture fully.
okay, okay,
Yeah,
means
like
5 minute or
no,
5 minute.
not 5 minutes. Last, when the connection got cut itself, I talked to you. You can continue.
Then it's mean 1 minute, I think.
Yeah, yeah, yeah. Yeah, usually this problem occurs when we are teaching, we will not be able to see anyone. So we go on teaching. So that's
Okay,
a
okay.
small issue there. So that you can continue, sir. It was now only.
Okay, no, no, that was the even that if the car was the picture, so Lucid Motor, they are basically using answers for the multi-physics design and development, and that was the last slide. I basically want if any participant is having any doubt, so they can ask me. So I am open for
Yeah.
that Q&A.
Okay, okay, okay. Yeah, participants, if till now, sir was just giving me the basic things that what are the availabilities. So you have seen that, and if you have any doubts, you can ask now.
So as we are using the student version, so what type of features are available there?
Uh, like you can say I have shown you something like meshing. So the meshing capability will be reduced, very much reduced, and some motor capabilities also that you cannot able to design. So means you can have the only capability of design and development at up to the basic level, not going to the advanced level.
And second, I think the calculation, the software taking very high calculation. It is feasible to run the our model in the simple laptop which we have using routine time, or we need a very high-fi level of the computer for that.
If
If I
your problem, if your problem definition is very simple, then it will require a very less configuration, not less, but you can say the capability should be up to you have 6 GB or 8 GB RAM in your system, and you also required at least i3 in your system. i3 should be there, more than i3 10th generation, that will be that much capable. And with SSD, so that by using that you can
Your volume is getting
some
cut, sir. I think some problem is there at your internet, like at your end with the internet. I think बीच बीच में cut हो रहा है.
okay, okay, now it's okay, ma'am.
Yeah, now it's okay.
So I basically want to tell you, sir, ki if the problem complexity is not that much large, then you don't require that much like simple system i3 more processor and 6 GB or 8 GB RAM, 8 GB RAM you can say. So that is capable for do the analysis.
okay, sir, thank you, sir.
Did all the participants install the software? Did you have any problem? You can put it in the chat so that when the time sir starts, if you have, you can have some issues in installation, you can do it. Because I too did it first. I found a little difficult, but it is easy only. It is not so tough. So I think many of you would have done it. But if you have any particular, like apart from that 32-bit problem, if you have some other problem in installation, you can just put it in the chat so that when before starting the session for practice and all, you can be ready with it. I think, yeah, sir, you can continue because like participants, if you have any doubts, you can ask. Otherwise, we'll tell sir to continue.
Hello there.
Yeah, call listen, sir. Yeah, you can.
So I want to find out is the answers uh, like a MATLAB, or can it replace MATLAB? If you have answers, you don't need MATLAB, like or it can do whatever MATLAB can do. I just want to find out.
That by using the ANSYS having the twin builder and the simpler part, by using that you can what MATLAB is doing.
Your voice again got cut, sir. Like last, we didn't hear it.
The ANSYS Implorer or the ANSYS Twin Builder, we can easily able to design what simulation will do in the
MATLAB.
MATLAB. So that we can do.
Pauline, one more thing I like to add up is here in ANSYS they have like say finite element analysis and in-depth analysis of temperature and all you can do. Some temperature analysis you can do it in MATLAB also, but I don't think so. Finite element analysis and all you will not be able to do it. So if you want to design a new motor and you want to look into the temperature and when saying even for the temperature of a thyristor or something you want to know, I don't think so in MATLAB such high end analysis is there. So like this is especially mainly for finite element analysis or when you're designing your own motor and you want to change the poles and other things, or you're designing the battery, or even high end things are possible in this. And the same thing what MATLAB has, such connections and all, they have another, like sir was telling, the twin builder and other things helps to do the same things what MATLAB does. Apart from that, here in-depth analysis can be done. Some analysis can be done in MATLAB also for thermal and other things, but yeah, there are some limitations in MATLAB. So here it is little more easy.
Okay.
Like you can visualize your whole design in the 3D. First, you can
Yeah.
design your whole system in the 3D model, and then you can analyze your whole circuit. But there in MATLAB, we are basically doing only a circuit level simulation. Here we are as a lumped circuit we are basically doing there, but here we will do part by part simulation and part by part analysis of our 3D design.
Yeah, when you anyway start doing this, you will understand since you have worked with MATLAB, here what type of things. So once they start and once you practice it, like when you start seeing what they are doing, then you'll understand it. I'm still clear. So are you going to continue with this session till 11 or how is it, sir? Kartikesh, sir?
Yes, ma'am. I will basically make them like portal, or they have already downloaded the
Yeah.
software or not, a student version, and how ANSYS will basically help them by
Uh-huh.
using it. I will make them familiar with the graphical user interface of the ANSYS if they
Right.
have no. So I will continue with
Yeah, you
that
can
only.
continue. Continue, sir.
Okay. Okay, so for that, I will basically have to change my system. So I will basically join with another system, and then I will show you how we can do that.
So participants till sir joins, I would like to have a small interaction with you. Say from 11:45, I have a lecture and till 1 o'clock. Okay, 1:15. So during that time, I just want you people to be little more active. See whether the volume is getting cut and whatever sir is asking, please respond it and make the session interactive as well as it is your responsibility. Mainly the coordinators at different centers. Please proactively you have to do that only this session actually. Yeah, thanks sir. So from 11:45 I'll be going for another talk which I have, so I'll be leaving at that time. So I just want participants to proactively do these. So sir will be showing you the the, as sir said, the GUI and other things, and he'll like in practice also you can do it parallelly, or we are doing the recording. So those who are not having this software, you need not worry. We will be sharing you the recording, so you can do it afterwards, like after you install. But those who have, you can just try it parallelly.
I am sharing my screen. Is my screen visible?
Yes, sir.
Okay. So when you open your AEDT, ANSYS Electronics desktop, it will look like this. You will get options like file, edit, view your project or the progress, project manager, status bar. Then we have the projects like which we basically want to design 2D modeling, 3D modeling, RM expert, and these are the tool library, windows, and the help. In help, you will get the some products information, customer support, what is new release, and what product improvement or about
Is
ANSYS.
there possibility of slightly increasing the font or zooming or something? Now it's okay, but I think in some of the centers they would have projected on the screen, and if it is very small, people who are sitting behind will not be able to see it.
When ma'am, they will basically start doing analysis now. They will get more familiar with these tabs.
Okay, okay.
Hello there.
Mainly the font size I'm talking about. Now also when they want to see, many of them are sitting in the lab. They'll be far
Okay.
away. That's why I'm saying, but I could see. I'm not sure about the other centers. How?
Let me check.
Hello.
Yes,
If
sir.
you can
Calling,
change
sir?
the color of the mouse pointer, it will be very helpful to us.
Yeah, yeah. Let's see that.
Okay, that I think that will take time, like installed default. Okay, so that will take time. So I will
Yeah, in
change that and
while
then
break or something, you can try to change it. I think
yes,
the
yes,
mouse color
yes, yes.
with our system itself, we have to do it. But now it's okay. When we take
Uh,
the break, you can do it. So you can continue.
okay. So when you open your ANSYS, so you will get the options like file, edit, view, project, tools, window, help. In that also, like if you go to the Maxwell and if you click on the Maxwell 3D we want to design, so we just have to click on that Maxwell 3D, and then we can see here we have two options like draw is added, modeler, Maxwell 3D, tools, window, help. In that help option you will also get the Maxwell PDF. So in that PDF, if you open that PDF, it will basically open the PDF that is related, and here you will get others information like how I have to start drawing my Maxwell 3D, how I started with the Maxwell user interface, modeling, meshing, boundaries, conditions, results, some project example also you will get in that help. By using the help, clicking on that, you will means more familiar about that part. You can also see that. And in that project manager, you can see here we have the project manager. In that you will see the first we have selected the Maxwell 3D design. So you will get the options like magnetostatic. This is the by default it is selected. So if you want to change the solution type, Maxwell basically work on magnetic and electric solution. In that magnetic, we have the options for the solver like magnetostatic solver, ED current solver, transient solver. In electric, we have the electrostatic, DC conduction, and the electric transient. So these are the options for the solver we have. So if we want to do the electrostatics analysis, we will click on that, press OK. Now you can see in the project manager it is changed to electrostatic. And then if you want to change the unit of the, this is the modular page, and this is the message manager. If you change something and the some problem or the error will occur, so it will be shown to your message manager. And when you run your simulation or when you run analyze your simulation, so that will
Sir,
be
I'm just
comes under the
interrupting one
progress
second.
part.
Karthik, sir,
Okay.
sorry. So when you were telling, I was also trying to open it. Sometimes now, like suddenly when I go there, miss it. So will you be giving us a practice separately, or should we do it now, or just we have to just look onto this now?
No. First, till 11, you just look into that,
Look,
and
okay.
after 11:30, you will. I will basically
Give,
make you how we can
do it.
design the 2D and
Okay, okay.
3D
So now we
model.
have to just see it. So that's what I. Okay,
Just,
thank you, sir.
just make. I am basically making comfortable with the tool. Like if at that time at 11:30, if someone open and they will think about like you have to go to that ribbon,
Okay,
they will
okay,
not able to see that. So that familiarization with the tool.
okay, okay.
Okay, so you can see here we have
One
the
second,
options
can you
like
show so that Maxwell 3D you opened and some solver window came? How did you do that?
ma'am, for that, like if I will go to that Maxwell
Okay,
3D,
solution type.
yes,
Yeah,
in
yeah,
that
okay.
also you will go
Mhm.
click on that solution type, and there you can see the magnetic and the
Okay,
electric.
yeah, yeah, yeah.
So from there you can see if you want to change the product project like from 2D, or we basically from are in 3D page, but we want to go to 2D. So if you click on that 2D, so it will open the 2D model, x-axis and the y-axis, and the 2D model design by default magnetostatic is there. So if you just double click on that, and then if you go to the Maxwell 2D, there you will find the solution type. Here we have options like magnetostatic, ed current. Here one more options is available to you in 2D, like geometry mode selection, like Cartesian, or if circular or the round coil is there. So then we will go about we will select the cylindrical about z axis. So that also we can select and the press OK. Now you can see there is a change in the project manager, magnetostatic and about the z-axis. If you create something like one box, we will create it. So just we have to click at this one like that. Only one collect point is there, and then if you click or create one box, now you can see the box is rectangle is created. So now you can see the rectangle one is created, and if you double click on that, you will see the attributes of the uh, box as a name rectangle one, material vacuum. So we have to change the material if we want, and we can also do the color change if you want. If you click on the color, you can change the color. You can also change the transparency level if you want. You can change, like you can say it is changing the color here. Press OK. Now if you see this one, we can increase that transparent label. That also we can change. Okay, so the other things we can also do, like if you want to create any model, we have options like four options are you can visualize here. But if you go to draw, here you will get also options like rectangle, circle, polygon, and the reason for when we are designing, then we are create separating our model with the other, so that then we will select the reason part. We have some user defined primitives, like example like rm expert. In that you will get the like coil you want to create, permanent magnet core you want to create, srm core you want to create. So just we have to click on that, and we have to give the information like length, pole, and the other information, and that will be created here, and then we can analyze for designing of our modeling. So when we will go for designing of that, we can also select, like sometime when you are analyzing and you basically have to create your model, and then you have to select the boundary condition for that. So for the selection of the boundary condition, you have to, this is the object mode. We are basically selecting the whole object, but at that time when the boundary is created, we have to go for the edge selection. So how we can do that? We basically have to select the object which edges is required, and then we can go with the selection of object with the edges. And after selecting that, now you can see we can only select the edge. So, and if I have to select all the four edges, what I have to do, I have to press the control button and then just click one by one, and then I have to click select the boundary. So this boundary condition, when we are analyzing our or creating a boundary, so that is the important part. Sometimes people miss this, and then they will get the result should be difficult to get, because we are not properly creating a boundary between the layers. And then we have to change this to the object. Now if you select the object, now we can select the overall object, we can see. So these things sometimes that is also required if you want to create or move your model. So that also, like if you click on this is the center point, if I have to move this along this line, this line, this line, so that also we can do, like movement of my, if I have to rotate that or create a mirror image, so that also, like from this axis, if I want a mirror image of this, so that also I can create mirror image. When we will design mirror image, like if the model is here, now it is, the point is changed. We can, if we want some, when we will design that transformer, that time we will see how we can do the split of our one rectangle with the other, how we can subtract that different part, so that also we will see. And then we will design our transformer, and we can also do analysis for the, if possible, then we will do the analysis for the 3D more transformer design. That also do, we will do one circuit analysis also. By using that, you can see there we have the project. In that project you can find the insert simpler design. Now when you open your insert simpler design, in that you can create link is also created, but that I think not visible for the student version. But in the answers we can also do that. We can also create a whole circuit and do the analysis according to that. Circuit design and development also we can do. Or so and for the other like Q3D 2D. So first problem what we will solve today, so we will
Sir, circuit
create what we
designing,
call
sir, circuit designing not available in the student version.
that I have to check up to what extent we can design the circuit design in and a student version. That we will also check.
Hello,
Okay,
sir.
so yeah, hello.
Please, do you have a library like Simulink in MATLAB where we
That
can
also,
get?
like if we are interested in designing, or if somebody is having the twin builder with them, so they can, like if I will show you by using that only circuit design. Now you can connect your whole design with your Simulink. That also possible, like ANSYS with the motor, like ANSYS with the MATLAB. The connection between the MATLAB and the ANSYS can be done by use, like co-simulation is possible by using this add
And
Simulink
I think
component.
your EV model, the thyristors and all those things are block sets only, no? You're just dragging, putting them and analyzing. Is it
Yes,
something like that? Yeah.
yeah,
This is for component level design, the motor and
yes,
all. This Maxwell will be useful. Is it, sir? Is it something like that? Like if you want
yes,
to design a transformer, a motor, or a
uh,
battery, then this will be in use.
that will be like making a connection between motor and your power electronics devices, like inverter with the motor. So inverter design you can do it here and then connect it with the motor.
Okay. That using the twin builder.
A twin builder simpler, earlier it is known as simpler.
Okay.
Now it is the twin builder. Okay, so if anyone having no doubt, so we will wrap up this session and then join at 11:30.
Yes. So now, like participants, anyway you have installed the software. So sir has also shown you. So you can, if you have time, you just explore it. Like go into different, so that it will be easy for you to know all these icons. What are they? So we have time. We can just go through whatever he has shown. You can just refresh it, and sharp at 11:30, the next session will start. And Kartikesh sir, at that time I also have a lecture. So I think you can continue as such. Okay, sir.
Okay.
And I've told some of my students also, if there are some interruption or something, they will let you know.
Okay. Thank you.
Okay, sir. Thank you. And participants at sharp 11:30, please join and start practicing. So I think we can start the session. So I just wanted to start the session and leave for mine. Is Kartikesh sir there?
Okay, yes, ma'am.
Yeah, Kartikesh sir, hello sir. I think other participants will also join. Few of them
So,
have left. Will join.
okay.
And,
Mhm.
yeah. Yeah. So, sir, I just hand over the session to you, and
Okay, ma'am.
while ending, I'll not be there because my session starts some 11:45 to one
Oh,
fifteen.
okay,
So you
okay,
can just wind off, and at again like 2:30, we'll start the session. So now I hand over the session to you, sir.
okay. Thank you, ma'am. And thank you all for joining. So we will wait for 2 or 3 minutes, and then we will start the session. Let the other join, and then I will start the session within 2 or 3 minutes.
Hello, sir.
Yes, sir. Hello.
Namaste, sir.
Namaste.
हेलो, आई एम ऑडिबल सर?
Hi. Yes, you are audible, sir.
सर मैं पूछना चाह रहा था कि जैसे कि मैटलैब सॉफ्टवेयर है, उसको हम लोग
हाँ
ऑनलाइन
हाँ
भी यूज कर सकते हैं। तो क्या अंशिस के साथ कुछ ऐसा है कि ऑनलाइन यूज कर ले बिना इंस्टॉल किए?
उसके लिए फिर क्लाउड बेस्ड एंसेस के पास सिस्टम है। आप उससे बस अपने सिस्टम से लॉगिन करके उस क्लाउड बेस्ड सिस्टम से आप लोग को एक्सेस कर सकते हैं
तो क्या वो
क्लाउड
स्टूडेंट
बेस्ड
वर्जन
लॉगिन के
उस
लिए।
पे है?
नहीं नहीं, वो स्टूडेंट वर्जन के लिए नहीं है अवेलेबल वैसा।
ठीक है सर, थैंक यू सर।
Yeah, is my screen visible?
Yes, sir.
Like overview and outline, coil and the slug torque Maxwell simulation. So we will do that simulation. We'll start how we can do that for the 2D modeling. So this is the problem statement. We basically want to create one coil of circular shape. Actual 3D model will be look like this. We'll basically create the circular coil, and then we have to create one slug is there, and then after that we will presently we will do the 2D analysis. So you can see here we have the 2D model. So just if you cut this coil, you will get a rectangular shape coil and rectangular shape slug. So that is the thing. We basically create one by one, and we will look into how we can design and proceed. So for that we will have to open ANSYS Electronics Desktop AEDT, and please open that in your system. And then we have to click on the Maxwell 2D. Next we have to go the first we have to select the solver. So for that only we have to click on the solver, and where you will find the solver in the Maxwell 2D. This is the solution type option is there. All people are like open the AEDT is open. So then I will proceed for solution type and creating the model. Hello, am I audible?
Dear sir, the screen is not moving.
No. Right now, I am just waiting for the confirmation ki people are
Okay.
started opening or that is
Okay.
opened or not.
Okay. Okay.
Hello, sir.
Yes. Hello.
Yeah, please, can you change your pointer color? Because of the background, I find it difficult to track your movement of your mouse. If you can change your pointer color for me, please.
Uh, Pointer color. Mm, That if anyone know how I can do that, like for the setting in the system setting, I can do that.
सब सीख लिया, देख रहा है पैसा दे रहे हैं हम सबको पैसा उठा रहे हैं ना। हाँ तो सोच रहे हैं।
So if anyone know
Hello,
how
sir.
I can change the color of the
Yes, sir.
pointer.
हेलो
Okay,
सर।
so for that, yeah, hello.
हाँ सर, कौन सी विंडो है सर आप में मोबाइल उसमें इंस्टॉल है?
Window 11.
सर जो नीचे टैब दिया रहता है जिसमें सर्च के लिए दिया हुआ है,
Okay.
सेटिंग में सर, सेटिंग में जाइए सर, वहां पे आप सर्च करेंगे चेंज माउस पॉइंटर कलर, चेंज माउस, आ गया सर पॉइंटर कलर।
Pointer size.
यहाँ पे आ रहा है सर, तो आप बदल सकते हैं कलर के लिए, आ जाएगा सर।
Okay. Thank you.
वेलकम सर।
Okay, so what we have to do basically, we have to go to Maxwell 2D if all are open their design, and then we have to go for solution type. And now you can see in this design, we have a circular coil, and that will be replicated by the rectangle, one for the coil and the one for the slug. So we have to put the material, change of material, color of the material, give the excitation, create a boundary condition. So these things we will do one by one. So this is the for creating the circular, we will basically select the cylindrical about z axis. So in this we have to go for geometry mode, cylindrical about z. So we just have to click on that cylindrical about z, and right now we want our magnetic field, so we will basically select the mag b. So for that we will select the magnetostatic solver, so we will not change that, and press ok. Press ok. Next step is to create a or change of unit. So how we can do that change of unit? Change of unit, go to modeler, we have to go to modeler. There you will find the units option, just click on that. Sometime we want our model to be in centimeter, sometime we want our model to be in mm, so we will have to click on this and the drop down will come, and from the drop down we have to select the unit, press mm, and then press ok. Next we have to draw a rectangle for the slug creation. So you can see the slug is from positive to negative, so we will set the points accordingly. So go to this rectangle part, draw rectangle. First option is draw rectangle, and second option is you can directly go to draw, and there also you will select the rectangle. So both are same, just click on that. Now the one pop-up will come like this. There you can see the change of your position, pointer changing with reference to the coordinate point 0 0. So this is the thing. So the next we basically have to now put the values in that. So we will put 0 in x-axis below the right hand side, 0. Press tab for the y. We will also, now you can see the according to that pointer value will also change, like black dot at 0 0.5. So there we have changed the value 0, then 0, then press tab and put the value of the z minus 10, then press enter. Now we have to put the other side of the x value, so that we will set it as the 5, then press tab. Y we will set at 0, and then we will set the z. And why we are doing, because we are basically putting one two this is the 2D modeling, so we already required uh, x r value and the z value, r value and the z value of the thing. So we will basically change this from 5 to 15 and press enter. Press Ctrl D. press Ctrl D to fit your model inside the modeler. So that we can do. Now the slug is created, and you can see we have the name as a rectangle 1. So that name as a rectangle 1 is created. Now we will have to change the name properties and the material information or the other things. So all are compatible, able to design that rectangle 1, or should I?
So we are not be able to give the value the way you have
Okay,
given the
so the
value, na?
values, okay. So the values you can see, if you can first create your rectangle, then I will first just draw that rectangle anywhere. And then I will give you the coordinate. So you can write the coordinate like this only, and then you able to create that.
Okay, how to change the coordinator?
You just have to go to the position, click on that, set the value x0, y0, and the z value is -10.
So how you open this block? This
Okay, just create one rectangle. The rectangle name as a rectangle 1 will be created. Then we have to create rectangle option is there. In that you just have to double click on that.
okay, got it.
हेलो सर।
Yes sir.
सर जब मैं ड्रॉ में जाके रेक्टेंगल पे क्लिक कर पा रहा हूँ,
हाँ
तो सर वहाँ पे ब्लैंक आ रहा है, जो आपने बताया कि कुछ लिख के आएगा, तो कुछ हो नहीं रहा है सर।
नहीं, आप कहाँ क्या बोल रहे हैं, नहीं समझ पा रहा हूँ मैं, फिर से बोलिए।
सर ड्रॉ रेक्टेंगल सेलेक्ट करने के लिए
हाँ, जैसे देखिए सबसे पहले हम लोग ड्रॉ पे जाएंगे, यहाँ रेक्टेंगल है तो उसको जस्ट क्लिक करेंगे, ठीक है। तो एक ये बॉक्स मेजर डेटा करके आ रहा होगा, जब भी आप पॉइंटर को इधर ले आएंगे इस तरफ मॉड्यूलर पे, देन यू कैन इजीली एबल टू सी चेंज and click,
सर
just
यहाँ तो
click
ब्लॉक
one
बन जा रहा है सर।
and this is the block बना पा रहे हैं ना आप, ये वाला ब्लॉक जैसे ये बना है।
जी सर।
हाँ, तो ये ब्लॉक जैसे ही बन गई ना आपकी, देन यू कैन गो टू दिस वन, लाइक रेक्टेंगल 2 बना है ये मेरा, you can see it here. So rectangle 2 is created. You just have to double click on that create rectangle. So this page will be open, this pop-up will come, and then we have to change the coordinates. Like you can see the position -6502.5, and the x size and the z size is 1.5 and -2.5. So for that only we have to write these things, like position 00, -10, x size 5, z size 15. So that we have to write.
I'm just trying.
Okay.
So जो एक्सिस y दिख रहा है ना मेरे में, इज विजिबल z. आई एम नॉट एबल टू चेंज z टू द y, the axis part.
Sir, I think you missed some part. Like if you go to this Maxwell 2D, in that
Yes.
just go to solution type, and here in the geometry you just select cylindrical above Z, and then press OK.
Again tell the option, sir, please.
Just go to Maxwell 2D, solution type. There you
Solution
will
type.
find geometry mode. Yeah, geometry
Okay.
mode.
About
In
z.
that you have to select yes.
Okay, sir.
Because for the circular thing we are basically doing this calculation.
Okay, sir.
Okay, now you have to feed the value. So I will just open, double click on that, and there you will find. Okay, so just put the value x position 0, 0, 0 for the x, 0 for the y, and the z -10 mm, and then x size 5, and the Z size 15. This is the RZ plane. Now we will change the name of the rectangle and we will change the material. So just we have to double click on this one, rectangle one name. Just double click on that. Just click single click on the rectangle and we will change the name to slug.
Sir, please, 1 minute.
Okay.
How did
Okay.
you open the model tab there? I cannot find it on my page.
Which one, sir? Which one? Modeler.
Yeah, the modular right now, where you
Okay,
open
so for that,
this worksheet.
okay, when you open the AEDT, you will find one options as a Maxwell, Maxwell it was written. So just you have to click on that. Like I will open that tab for you and says AEDT. If you open this one, okay, there you will find Maxwell. Now you can see we don't have modular option. So in the Maxwell, if you click on the Maxwell 2D,
Yes, sir.
just click on that Maxwell 2D.
Yeah, I've done that.
Done that, then you will find the modular option. The page will look like this.
Okay.
Okay, you found that modular?
Yes.
Yes. Now we have to create a rectangle. Just go to this one, draw rectangle.
Okay.
Okay, and then draw the rectangle and just set the coordinate like this.
Sir, I'm not able to change the name. We have to change the name
Just
in the command option.
we can change. Just let other to be on the same page. Then I will show you how you can do that. Just a minute. Okay, so position is changed according to that 0 minus 10, size 5, Z size is 15. Press OK. Now we will go for changing of the name, changing of the color, and changing of the material. So for that, we just have to go to rectangle one. You can see I just have single click on the rectangle one. If you double click on that rectangle one, just double click on the rectangle one, then you will find single click on the name. Now just press the backspace and change the name to slug. Okay, now you are able to change.
Yes, sir. Thank you.
Okay, and now the next step is to change the material. We want our slug material to be the steel. So what we will do, we will just click on the edit.
Three
And we
materials are
have to
available
select
there, sir.
hmm?
In student version, three materials are there:
Okay,
steel,
which one?
copper,
Huh.
and one more.
So just select the steel. Press OK. Now the material selection is done. We have to change the color to gray. Press OK. And you can, if you want, you can also change the transparent label. Press OK. Apply. OK. Okay, all have done that part. So slug creation of slug is done.
जल्दी बताओ
Now we will have to create a coil.
जैसे ये फाइल है ना अब यहाँ पर ये चीज लिखी हटाई किसने जाएगी जैसे यहाँ तो नहीं लिख के आ रहा है सब लिख के
Hello, can other participant, can you please mute if possible? Okay, so the slug is created. Now we have to create a, according to our problem, the slug is created. Now we have to create a coil. So for the creating the coil, the same we have to create a rectangle for this one coil. So what process we have to follow? We have to go to draw or just click on the rectangle and set the coordinate in the below right hand side. First x value as a 6, then tab 0, then press tab 0, press enter. Now you can see one coordinate is selected. Now I want next coordinate to be selected of the other side of x. 4, press tab 0, press tab 20, 20. Press enter. Now rectangle 2 is created and we have to press Ctrl D to fit the model. Or you can directly go to this option fit all and you just have to click on the fit all model. So the next,
Sir, excuse me, I am not able to actually draw the second rectangle. Nah? You are just trying to basically, I am only visible first rectangle in my screen actually.
and other are also facing the same. You are able to see the second rectangle or not? Please confirm.
No, sir.
Only one. Are you people able to see that two rectangle or only one single rectangle?
In your screen, we are able to see the two rectangle, but on not on our screen.
So that's why I am asking, sir, ki please you just tell me yeah, to from the beginning actually for the second rectangle how we need to let's say
Okay,
draw.
so the second rectangle, we
Yeah,
have to just
yeah.
go to the draw option in the upper ribbon. In that draw
Okay.
option, just click on that. You will get the drop down of the rectangle. Just in the drop down, you just have to select the rectangle. After selecting the rectangles, just draw anywhere, any rectangle you will draw. I will tell you the coordinates. Just change the coordinate in that. Like just rectangle 1 is created. So create rectangle option is there in that in the history tree. So from there you can set the position like this: x value 6, y value 0, and z value 0, and x size value 4, and z size value 20. Is it okay?
Yes, sir. Okay. Can you see the same the code value for the rectangle first? Same value for the rectangle first.
Okay. Now you can see. Zero zero minus 10, x size 5, z size 15. Okay.
Okay, sir.
Okay, so the next step is to we have to change the name. How we can do that? Change the name of the rectangle. So double click on that rectangle one. Here in the history tree, just click on that rectangle one, double click, change the name to coil and material to copper. Change the name, coil and material to copper. Apply. And if you want, you can also change the color to brown. Double click on that. Apply and OK. All are in the same page. If you face any problem, you can ask. Okay, so we will move further. Uh, all are able to create these two rectangles. One is slug and one is the coil. The next step, what we basically have to do, we have to protect our circuit from outside environment. So what we will do, we will we can also draw a box and we can keep our circuit on that, or directly you can go to this red box that is create reason option is visible to you, where you have to go create reason. In the ribbon part you can just go there, and there you will find a create reason options. So just we have to click on that create reason, and then you will get the options like pad all directions, similarly pad individual direction. So this will basically give you freedom, like when you want only packing, not thinking about the computation and the timing. So then what we will do, we will select the pad all directions similarly. When the system is very complex, then what we will do, we will do the padding individual direction. Means the length of the padding will be according to our application, and otherwise we can also do the transverse padding. So here with the we don't have the complex problem. So what we will do, we will select as 100 and press OK. Now you can see the length, you can see the press Control D first to fit the model. Now you can see the like, or you can do the fit all also you can click. Now you can see the distance between these two, like whole model will be like 100%. So that's why it is showing you the length. Like you can also reduce this gap if you want. You can reduce these gaps also, you can reduce this gap also. Okay, so but now we don't have this problem much bigger. So what we will do, we will basically reducing that. The next, after all set, the reason is set by you, all are comfortable in setting the reason. What we have to do, we have to go to this red box create rectangle. Then we have to like I have already created 100%, so that's why it is showing R as 100, Z as 100. All are in the same page.
Yes, sir.
Okay.
Yeah, sir. Actually,
Okay.
yes,
Uh-huh.
sir. Actually, by mistake, let's say for
Mm-hmm.
coil itself, I think one
Okay.
coordinate is changed by mistake. So this element, coil rectangle, basically is coming out from this reason, sir. Actually.
Okay, so you can see here, you can set the coordinates. I am just opening the create rectangle option. Now you can change the coordinate or just
Yeah.
take the screenshot or the photo. So that
Okay.
will helpful for you for when you will redesign you by yourself.
Okay. You are given X4 and Z is 20, na?
Yes.
Okay, sir.
Now it's okay.
So I am just clicking. X is 4 and Z is 20. But in this position, it is showing, sir, minus 5.50, comma 12.
Then you can change this position also. Just double click, give a single click and set the position.
And sir, what are the coordinate we need to give in the position itself?
6,
Eh,
6, comma
6.
0, comma 0.
Okay, comma 0. Okay, sir. Fine, fine, sir. Got it.
Okay. Press OK. Now all are in the same page.
So how do you set the color? Because I'm not getting a color part, because one is seeing brown, one is seeing the
Hmm.
gray,
Okay.
and the
So
region
in
part
the
is transpose. So that's the issue on my side.
like you can just go to this create rectangle or just go to this one first coil. Just go to this coil, double click on that. Now you can see the color option is here. So by using that you can select the colors.
Okay, sir.
Okay, are you able to change that?
Yes, sir. Yes, sir. Done.
Okay, okay. Okay, so now we will the next, like the geometry creation is over. Now what we have to do, the coil is created with the copper. We have to give certain level of excitement to the coil. We have to give current. So here we are using the current excitation to excite our coil. And here what and why we are doing this, we will have to see the magnetic field. So that is the our goal. And we also want to see if due to this coil or we are giving the current, what the amount of force it will apply to this slug. Okay, understood the problem statement? Ki we are providing current to the coil, and due to this current the slug will get some force. So that force value we are basically calculating, first thing. And second thing is that ki we are calculating or we will also see the current, or we can see the magnetic field due to that current. So these two problem we are right now we are designing this 2D model for that only. Okay, so now we have to give check the or we have to give the excitation. So there are many others method or there are many things like we have how we can do. First you have to go to history tree. So this is the history tree. We just have to give a single click on the coil. Just give a single click to the coil, press the right mouse button there, go to coil, press the right mouse button there, and there you will find the assign excitation option. Okay, all are this assign excitation is visible to you. Then you have to click on the current and we have to set the value of current as 100 amps. So we will click on this one, the drop down will come, and in that drop down we have to click on A, and you can see refer direction positive or negative. So here what we will do, we will select a negative and then press OK. Now you can see where we have to go for the excitation or where our excitation is gone. So if you want to look on that, go to that project manager window. In that project manager, you will find the excitation option here. In that excitation, you will find the plus sign. So just click on that. Now current one is excited and you can see the properties of that current below that. Now name is the current one, type is the current, and the current value is 100. We have set the direction to the negative. Now what is the negative and positive? This one, like inside the page is the negative positive and above the page is the negative. Okay, all understood this point? How to set the excitation?
Sir, I'm
Yes,
not able to
yes,
see
sir.
this excitation in a project manager tree.
Arch.
Yeah.
In your project manager, this excitation, like current one, is not visible to you.
Yeah, sir. Excitation is not visible.
Sir, it is there. First we click on the coil, right click there, and
Yes,
just
yes.
go on
Just.
assign excitation.
Mhm.
Then
Yeah.
set, I think,
Okay.
current value, na, sir?
Yes, 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 ma'am.
Okay, how much value, sir, we have to set?
100.
100 milliamperes.
100 amps.
Amps. Okay. Type and direction we don't have to set, na?
Set, ma'am, direction to negative.
Negative. And type
Press
solid.
OK.
Okay.
Yeah, it is visible, sir.
And then how these properties will come, sir?
Which one, ma'am?
So this properties, like their name and everything is coming.
Okay. No, no. That you have to go to this project manager. First, go to project manager. There you will find the excitation and the current. Just click, give a single click on the current one. There you will find the properties. Okay. Next, like excitation of current, we have already given. Now what we will do, we will have to give excitation to the slug also. Like we want to calculate the value of force or torque. Sometime if torque is required, then we have to assign torque. But here in this problem, we want a force. So we have to set the force excitation to this slug. So for that only, from the history tree, just click on the slug, press the right mouse button, assign excitation. Here we want to assign a parameters. So we will go to assign parameters, go to force. Just click on that force, press OK. Now you can see in the project manager, in the parameter, the force is excited. In the parameter, we have assigned the force.
No, sir. We need to go for the same procedure. Na? We need to follow.
Same process. Like you just have to select the slug,
Yeah.
press the right mouse button,
Yeah.
assign parameters. There you will find force or matrix. So just click on the force. Press OK.
Force. And in the name is force. It is force
Force
one.
1.
Force one. Na?
Yes.
And just
Yeah,
okay,
yeah.
na?
Just OK.
Okay.
Okay, so the parameter, what we have covered till now, we have started a problem, a coil having a current. We have to calculate the value of the force on the slug. So this is the problem statement. And we have started by drawing the rectangle 1 and rectangle 2. We have able to, now we are able to change the name of the coil, like rectangle to coil. We can change the color, we can change the material. All things are done geometry wise, and the other we have created the reason also. The next we have also give the excitation to the coil. We have also given the parameter and parameter values to the slug. So that all things are over. Next, what we will do, we will create a balloon, and what we will do, we will basically give the boundary condition to our model. Due to that only, we will, what we will do, these things, the outside thing that is present outside, outside from the box. What I will do, we will basically create a reason on the like outside environment will not affect the system. I want to check my system behavior within that box of the reason only. So for that only, what we will do, we will have to just click on the reason, just click there in the box, anywhere you can click, just click now, or you can directly go to history tree and click, single click on the reason, go to select object. In that you have to change this to age. First do that part, select age, or if that age is not visible, then you can go to edit also. In that edit, you can get the option like this, selection mode from object to edges. So just we have to click on the edges. Okay, done. So and now you can see, if you click, if I will click, I will able to click on the edges. Now I have to select the edges, so I have to press control button. Just press the control button, select all the edges, 4 edges, press right mouse button, assign boundaries, click on the balloon, press balloon 1 will be there, press OK.
Sir, please repeat.
Please repeat, sir.
Okay. So the first what we have to do, we have to click on this reason history tree. Just click on the reason. Then go to select age. Okay. And then press the control button, and just control button cannot lift your hand from the control button. Just press that control button and select one by one, 1, 2, 3, all the edges of the reason. Okay, after pressing this one like selection, and then you just have to press the right mouse button, assign boundary option will be visible to you. Okay, you will reach that point, and then balloon option is there, just click on that, then balloon 1 will be created. And that you can see in the project manager. You can see if you click on the balloon, the blue color boundaries is created.
And click in OK, no, sir? In the project manager, it is showing in a, sir, blue color, but in the screen, in the graphics area, it is not showing in blue color.
Okay, but balloon 1 is created, na?
Yeah, sir. Yeah, balloon 1 created.
Okay, for the whole boundary.
Yeah.
Okay, then it's okay. The next step is we have to run the simulation. For running that simulation, we have to analyze our circuit. We have to go to analysis. Okay, so if anyone all are in the same page.
Yes, sir.
Yeah.
Okay, so now we have to only analyze our circuit. Like we have already created the geometry, excitation, parameter, boundary condition, all we have already set it. Now only we have to give the analysis and we have to analyze our circuit. Okay, so what I will do, we will basically take a break of 5 minutes and I will rejoin it at 12:25. Okay.
Okay, sir.
Okay, sir. Okay, sir.
Anyone please help me out? How can we open a new project in this? Because I am working, editing the old demo in that ANSYS.
I think file new. On the file, click
Yeah,
new.
after that, that project one option is coming. When we click on plus, definitions coming, symbol, component, material. So how that script will open?
Double click on one particular project that will be open.
No, it is not coming in my screen.
You may share your screen, ma'am.
Okay. Yes, sir. Now,
Double click on project. Okay, now go to the project on the menu bar. Insert Maxwell 2D. Okay, ma'am.
yeah, thank you, sir.
Okay, ma'am.
Yeah, Javed sir, can you hear me? Hello.
Yes, sir.
Yeah, sir. Actually, you just tell me, na, for the slug part, na. Actually, I'm just going to share my screen and
So you may share your screen.
yeah, 1 minute, sir. Are you able to see this, sir?
No, sir. Share your all the screen, whole screen.
Share. Okay. No, sir. Is it visible?
Yes, sir.
Sir, actually, no, you can see the slug part, na. It is let's say just lies. I think position is different by some mistake. So can you change the
I
position?
think coordinated different. I think you
Yeah,
may
yeah,
click
yeah.
on slug part. Click on the
One,
slug part.
1 minute, sir. 1 minute. Click on the slug part.
Create
Yeah,
rectangle.
yeah.
Then come to position.
Position.
Give me 1 minute.
It is 5015 showing.
1 minute. So 1 minute.
Yeah.
The position is 0, 0, minus 10.
Okay, position is so
0,
1
0, minus 10.
0 0 y0 and z is -10. No?
Minus 10. X size is 5.
The x size is 5.
5. Yes.
Okay,
And Z size is 15.
and z size is 15.
Enter.
Okay,
Okay,
now
done.
yeah, thank you, sir. Thank
Okay, sir.
okay.
Okay, am I audible?
Yeah, sir.
Yes, sir.
Okay, so the geometry part is over. We have give the excitation, that is also over. The last step we have to do the analysis so of our circuit. So let me share my screen. Now is my screen visible?
Yes, sir. Yes, sir. It is visible.
Yeah.
Okay, so we have to go to analysis in the project manager. You can see we have the project manager. There you can go to analysis. Just click the right mouse button there. Then we have add solution setup option. Just click on that, add solution setup. There you can see the options like maximum number of passes. You can see it here. So the maximum number of passes we have set it as a 10. Here it is by default 10. If you want, you can also increase, and the percentage error is 1%. So what does this means? This is number, not the number, or this is the number of iteration, you can say. So here what we are doing, like how ANSYS Maxwell will basically work. It will for the meshing or creating or solution, it will basically create a triangular shape for the 2D and tetrahedron shape for the 3D model to do the FEA analysis. Okay, so that's why we have to set the number of passes, means number of the size of the thing we like tetrahedral thing or the triangular. We are basically, if you increase the number of passes, this means the more and more deep simulation will be happen, or the size of the triangle will be goes on increasing. So when we analyze this, we will see the number of triangle it is created to achieve our desired result. So for that we have to just click the right mouse button in the analysis, add solution setup, then set the number of passes as 10, or you can reduce it to 8. Press OK. Press OK. Now, and you can also change the select to object. Select, here we have selected as the other, but you can select it as a object. Okay.
Okay, sir.
Okay, so now press Control A. Press the button Control A. Press the button Control A to select all the object that is present in the model.
Sir, please repeat it.
Okay, now leave this one first. We will go one by one. So first, the analysis setup is done.
Yeah.
Is this setup is done? Okay, then just go to setup. Press Control but right mouse button in setup and press analyze. It will show you to save your model. So we will save it as a 2D
Setup, sir.
file.
We are not able to
Okay.
see setup.
Like just in the analysis, next to next analysis.
Yeah, setup 1. It is showing setup 1.
Yes.
Yeah. Then.
So press the right mouse button there.
Yes, sir.
Analyze. First, it will tell you to save your model. So I will save in the name of 2D and ITTR and press OK, like save. Now it will, the simulation is started. So you can see the progress. It will take some time. Uh, okay, if analysis will completed in any other system.
No, sir, it is running.
Okay.
In the sir, let's say you can say the in the bottom right hand side is showing the show
Progress.
progress. Show progress.
Yes, yes. Yes, yes, yes. Okay, so now the simulation is completed. You can see in the message manager, normal completion of simulation on server.
Sir, how we can see the message manager? Because in my screen I'm not able to see this.
So then you go view.
View.
In that,
Okay.
you just click on the message manager. Yeah. Message manager.
Yeah.
If that is unchecked, you just have to click on the. Okay, now we have to see the value of force and the value of magnetic field. When simulation is confirmed, please let me know.
Sir, please, how do you simulate?
Okay, simulation is completed.
Yes, sir. Yes, sir.
Yeah, okay. Then we have to see the results. Okay, so for that we have two options. You can go to Maxwell 2D, click on that and then go to results, or you can directly go to project manager. There you will find the results. Just press the right mouse button there. Okay, just press the right mouse button in the results and then go to solution data. You will see the value of force. Okay, so we will change this to Newton to, now you can see 3.3879. Getting the same result.
Sir, in my message manager, there is some error is showing, sir.
Okay. What error you are getting?
It is, let's say, showing, sir, there are 2.2 cross in a red color is showing solving for magnetic adapting pass 1 process solve 2D error. And second one is simulation completed with execution error on server local machine.
Okay, that we have to check. Okay, so when the break will happen after one, we will connect for that. Okay.
Okay, sir.
Even on my system, it is showing that student limit is over
Okay,
of
so
this version.
I think you have already used by using that login or something that already you have used. So, or somebody
How
has
many
already
time we
used.
can use this student trial version?
So that trial version is for 1 year. You have to re-register with other name, other email ID, and the other. Then you can use as a
But
other
sir,
student.
recently I have downloaded it. First time I have downloaded.
No. Okay, and otherwise, I think that for the same system, you are using your laptop or
Yeah, it's
college?
mine, sir. First time I have
It's
installed
yours.
this thing.
Okay, just then I will connect with Tushar sir. He will look into that. Okay,
Okay, sir.
why it is showing this error. Okay, so when just take the snap of this, when the error will over, you will just check your results. The results should be like this only. Okay, so you will get the force value 3.3879. And when we do, how we have to do the uh, like magnetic flux density. So for that we have to go to Maxwell 2D. There you will find the results, or right now you just go to project manager, go to field overlays, click the right mouse button there. Then we have to go to field, then we have to go to B, and then we have to click on the magnitude B. So select all the material, control A, go to field overlays, go to field, go to B, mag B. Now you can see that this is the value of B. Okay, so if some simulations where you, if you are getting the result, please confirm. Anyone getting this result?
So to analyze it not working, showing errors. I don't know.
Okay. What error you are also getting?
So solution have been invalidate.
Okay, can you like share
Can I
your
can I
your
share
okay? So
screen?
that, yeah, that we will do, I think, after when that one simulation, this one is over. Then we will go for Q&A if anyone having any doubt, and if they don't have any doubt, like after 12:45, then I will connect and I will look into that. Okay, sir.
Okay, sir. Okay, sir.
Just give 5 minutes to the others, so they will able to simulate that. And if there is no Q&A, we will connect for that. Okay. Yeah. Anyone getting this result, or all then or anyone having doubt in that, so they can
Sir,
ask.
please repeat the process again.
Means you want field overlays.
Yes, repeat it. Yes, sir.
Like after analysis, you have done your analysis setup part. That is done. Yeah. Hello. Am I audible?
I am not able to obtain your output right now. So how you
Okay.
went to field
Means,
overlays?
okay. Okay. You just this setup is, you have done that part in that like setup part, number of passes, percentage error one, press OK.
Okay.
That part is done by you.
Yes, sir.
Okay, then you just have to save your model. Like I have saved it as a 2D NITTR. Just save your model name,
Okay.
and after saving, when you save that, just go to setup, below the analysis, press the right mouse button, and then you have to click on the analyze.
No lights.
Yeah, it will take some time. to analyze, and that will be shown in the progress window. You will see the result of the progress that will be present in the progress. नहीं. Okay. Are you the simulation is started running?
Yes, it has completed, but my
Okay.
results are different from what you have.
No. For that, what you are getting your result, like you just have to click press Control A first, and then go to field overlays, and there you have to click the right mouse button, field B, mag B. But you are getting the B value, na?
Maggie.
So I got the result. The same
Wow.
result. I
Okay.
don't know what was that. I got it.
Okay. Okay. Anyone or get the result or any doubt? So otherwise we will look into the other system and what problem they are facing. So that also we will look if anyone is not having any problem.
So the same error is showing, sir, in the message manager.
What you are getting?
So can I, let's say, share my screen, sir, or?
That we can do if
Yeah.
anyone having no doubt. So just share your screen.
Okay, sir. I'm
So I
sharing my
will
screen.
just stop sharing.
Yeah. So, is it visible?
Yes, it is visible.
Yeah. So this type of message is showing, sir.
Solving the magnetic data was one process. This one currently excitation could not be applied to the non-conductor. Okay, just open the coil in the history tree. Just open the coil.
Yeah.
Just double click on that.
Yeah.
Now you can see material you have not changed. You have to change the material to copper. That is material appearance. Above that, next to the
Okay.
name. Yeah. Yes.
Yeah.
There you have to select the copper. Copper. COPP. Just type the name.
Copper. It is this one.
Yeah. Just press OK.
Okay.
Apply. Okay.
Apply. And then okay.
Now analyze.
Now once again, I need to go for.
No. Only setup one. Just click on that setup one.
Yeah.
Press the right mouse button.
Yeah.
Analyze. Okay, it will take some time. Now it's done. Just go to results.
Results.
Press the right mouse button. Go to solution data.
Solution data.
Now you will able to calculate the value of the force. So, but you are getting in a negative. Okay. Why? I think the direction of the current you have not changed. So that's why you are getting the negative. Just open the excitation in project manager.
Excitation.
Above current one. Just open that current one. Double click.
Yeah.
Here you have selected the, okay, that one is positive, that is okay. Then go to torque, just go to force one, open that force one parameter.
Parameters, force one.
So I think slug material is also not
Acha,
proper.
assign na. That also we have to check. Cancel this one.
Yeah.
Just open the slug.
Yeah. This slug.
Material selection. Yes, correct. Material. Change the material to steel.
This is simple.
Steel 1008. Yes, yes. First one. The first option you are
one.
getting. Just click on that. Press OK.
It is not taking, sir.
No. Just press OK. And then press OK. Yeah. Cancel
it
this
is
first.
in the
First
material.
cancel this.
Okay.
Yeah. Just cancel this. Now open this edit.
The
I
material.
think more than one material is selected at that time, so that's why it is creating problem. So just click on that. Yeah. Edit. Right steel ST. Double EL. Yeah. 1008. First one. Just click on that and press OK.
Okay.
Now
And
apply OK. Yeah. Okay.
And okay.
Now run the simulation analysis. Like setup one.
Setup one.
Press
Double.
right mouse button.
Yeah.
Analyze. Okay, now see the results. Just go to results.
Yeah.
Right mouse button. Solution data.
Solution data.
Now you are getting the same result.
This is this one.
Okay.
Okay. Then
now go to field. Press Control A.
Control A.
To select all the object that is present in the modeler. Okay, first change. No. First change the select edges to object. Upper side, upper left hand. There is an option select edge. So that just change that. Above, below draw. Or modeler. Yes. Select. Yeah. Change this to object. Press Control A.
Control A.
Yes. Now press right mouse button anywhere.
Okay.
Now go to field.
Fields.
Yeah. Go to B. Mag B. Press OK. That is Mag B is already selected. Press done. Now you can see.
Okay, sir. Okay. Thank you. Now I am stop sharing. Huh?
Yeah. Or if anyone having any problem, they can share their screen. Or if all are getting the results, so
Hello,
we will wrap. Yeah. Hello.
Yeah, please let me
Yes,
share
yes.
my screen.
Okay.
So this kind of 3D models we can analyze in this ANSYS, right?
Yes, this is the 2D, ma'am. We will also do the 3D analysis next.
Okay, for our transformer and electrical all
Yes, ma'am.
machines we can like create power system and all, right?
Yes, ma'am.
Okay.
Yeah, share your screen.
Please, can you see my screen?
Yeah. Just it is. Yeah, you got the result. Okay.
Look at the down here.
Yes. You are getting the same result. What happened? You can see. Just see my screen. I am sharing my screen. You are getting the same result, but you are getting it for the full model. What we are done, We are basically done for our half model. You are getting your result for the full model. Just let me explain. Let me share my screen, and now I will make you see why you are getting this. Share. Now is my solution, or is my problem statement page is visible to you?
Yes, sir.
Yes, you can see here what we have created. We have only selected that part. That part we have only selected. This one is the slug and this one is the coil. But you are getting the result for the whole simulation. So if you cut this part, okay, you will also get rectangle here. Slug part is also there. So you are basically, like, if you create a mirror image here, slug will be present here, and this part. Uh, okay, so how to draw this one? So you will, if you create your mirror image now, you will also get this one. This part will be visible to you here, and that rectangle is also visible to you here. So that's why you are, when you are creating the model now, you have not unchecked that full model. So that's why you are getting the result like this.
Oh, okay, okay.
So why we
So,
are giving the current excitation negative?
We have given the current excitation negative because we want our solution, like our current value should be like inside to us, like from coming out. If you want, you can also change the direction like opposite to that. No, not to worry, you can also do that. For this problem only, I have selected like this.
Okay, sir.
This is the coil, and we have selected like current is going like this direction. If you want, you can also change the direction according to your design. It will be,
So that means current is flowing from primary to secondary or secondary to primary. That is negative and positive. We
no,
can
no, no, no,
change.
no, it is
No?
not. It is the only coil, and we are
Okay.
giving excitation to only one coil, and we are
Mm-hmm.
like solenoid. You can consider one coil is there, one slug is there,
Mm-hmm.
and we are calculating the value of force.
Okay.
Sir, can
Go
we,
ahead.
let's say, can we able to see, let's say, convert this result, let's say, from the 2D format to the three-dimensional model, or let's say, firstly we need to create the 3D model and then we need to go for analysis.
We basically like sometime we can do that, like we can directly convert our model to the 3D. That option is also possible, but there we have to think about the symmetry. If I have created the symmetry, like I have created rectangle, but if I will able to create half of that or quarter of the design, then I can use that, and I will get the result for the full model.
And if we replace the slug by the coil, then we have to mention the current density for the coil in negative or positive. I'm just want to clarify that.
No, you no no. If you want, you can do anything in that. The system will not harm you. So
No, no.
just the problem which comes to your mind, now just do it. I
Okay.
basically want to like play with the software, see the result.
No, I was just a question how I can represent that my field is moving from primary to secondary side. So the negative to you say that the field is moving outside. So for secondary coil, I will take the positive value.
No, no, this is
Um,
not the primary and the secondary. Now we are basically one coil is there and one slug is there, and we are calculating the force on the slug.
if we replace the slug by the coil also.
That also we can do.
Okay.
Okay, so now we will wrap up this session and we will join at 2.
Okay, thank you, sir. You explain each and every step very well.
Thank you. So we
Yeah,
will meet at 2.
yeah, thank you, sir.
Okay.
So, very good afternoon to all the participants. And we are in the afternoon session of the fourth day. So now we will be looking into the RM expert as well as the machines modeling of using this ANSYS. So I think our expert Karthikesh sir is here. Sir, have you joined? Karthikesh sir? Karthikesh sir, have you joined?
Yes, ma'am.
Yeah, yeah. Okay, sir. Thank you.
Okay, so we will wait for 1 or 2 minutes maximum, and then we will start.
Yes, sir. Karthikesh sir, I think we can start.
Okay, ma'am. So let me share my screen. So yeah, is my screen visible?
Yes, sir.
Okay. So first we have already simulated for the 2D model. Now we will basically go for design and development for the 3D model. So just look into that. We basically have one coil and we will excite we will give a excitation current in this coil, and one magnet we will put in that, and we will see the value of the torque in that. So we will see how much torque it will produce due to this current. And also we will basically rotate this coil to 45 degrees. So this is the thing, this is the problem statement. We have similarly what we have already done for the force, right now we have to do for the torque. Okay, so we have to open AEDT. So okay, so we have to select all will open this one AEDT, and then we have to click on the Maxwell 3D. Okay, so the next step after selecting this, what step we have to follow? We have to select the solver. So for selecting the solver, where we have to go? Anyone from the participant? For selection of solver, where I have to click?
Participants, please answer.
The similar method we basically have to follow for like 2D, which we have done. We have to click on the Maxwell 2D. Here for the solver, we have to click on the Maxwell 3D. Okay, and then we have to go to solution type. There you will find the solver like magnetic and electric. So here we are doing the same analysis for the 3D, so that's why we don't have to change that. Otherwise, when the next example we will solve, so there we will go for ED current analysis, and after that we will go for electrostatic analysis. Okay, so right now we are interested in only 3D modeling, so we will not change that, and we will press OK. And the next step is to make the modular unit in millimeters. So for that we have to go for modular. In that modular tab, just go to the modular, and then we have to go to units, and now it is by default that is mm, so we don't have to change. And if we have to change, we just have to press the tab and the drop down will come, and from this drop down we just have to click on the mm and press OK. Okay, all are in the same page?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Okay, now the next step is we have to create a polygon. So for creating a polygon, we have where we have to go, we have to draw the polygon. So drawing the polygon, we have to directly, you can select from here, or you can go to draw and then click on the regular polygon. Okay, when you click on the regular polygon, it will basically show you the point like this. Okay, when we will selecting the box, the same thing will happen. So here also you will get the pointer like this. Now the next step, go to the below of your right hand side. In that you will find the x, y and the z axis. So there we have to put the values. So we basically want enter the first center position of the polygon. So center position of the polygon we will select as x as 0. Then we have to press tab to go to the next y. So we will have the value 5, and then z value we will select as a 0. Press tab and then press enter. Now the other coordinates we have to set, like the other radius we have to feed. So the x we will set it as a 0.5. Then we will press y as a 0. Then press tab dz as a 0 and then press enter. Now it will ask you the number of segments. So what this number of segments signifies? that we will look like first I will set this value like dx value to be 0.5, press tab, then this value is 0, then tab 0, press enter, then press OK. Now you are not visible because we have some distance on that in the regular polygon, but my regular polygon is present in the history tree. So what we have to do, we have to do the fit all, and for the fit all option, what command we have to provide? Directly you can go to and click on the fit all, or you just have to press the Control D. Okay, and this is the segment, like 12 segment we have selected, so you can select 1 2 3 4 5 6. Likewise we have the 12 segment, means if we increase the number of segment, it will look like similar to the circle. Okay, after designing this regular polygon, the next step is to change the name of the polygon. So how you can do that, how we will basically do the change the name? We have to go to history tree. In that we have to double click on the polygon, then we have to give a single click on that, press backspace and coil, press OK. Now the name is changed to coil. All have created the coil.
So give me 1 minute. We try it now.
Okay, yeah, okay. Okay, so the code for coordinate, I am just opening this tab, double click on that. So this is the coordinate.
Hello, sir. Hello.
Yeah, hello.
सर रिकॉर्डिंग ऑन कर दीजिए.
Yes. Recording?
जी सर, लेक्चर.
अच्छा, recording is not on.
जी
Okay.
सर, प्लीज टर्न ऑन इट.
Okay, so anyone from the can you please turn on the recording?
Gopal, you started the recording, but did it get stopped? Gopal?
Okay, so recording is started. Okay, is recording started?
Hello, sir.
Hello, have
sir.
you created this? Yeah, hello.
So I've entered the dimensions.
Am I
but,
audible?
yes, sir.
Okay. You can see the dimension.
I have entered the dimensions, but the polygon is not
Okay.
displayed on the page. Why?
Press Control D. Press Control D.
Control D. Okay. Thank you.
Now it is visible. Okay. Or you can also click now after designing any circuit or any designing, you can just go to this option, like you can see fit all option is there, just click on that.
Okay, sir. Okay, thank you.
Sir, I have one doubt, sir.
Yes. Okay, okay.
Please tell
Yeah,
how
go ahead.
to give dimension in regular polygon.
uh Directly, just go to the regular polygon in the draw option, just click on that, and then you can see the regular polygon option is there. Okay, so just click on that and just drag and drop and create one. Okay, it will ask you number of segments, just press OK. This polygon is created. Now just go to this create polygon. Now we have the center position, we have the start position. Okay, in that we just have to fill the coordinates or fill where we basically want, so that coordinate we have to fill. Understood?
Okay, sir.
And this is the value of the coordinate which I have filled. Like for center position you have to write 050, start position 0.550, and number of segment 12. After that, change this name to coil. Okay, all okay, shall we go?
Yes, sir, done.
Done. Okay, now we will go for making this
Done, sir.
polygon to work as a coil or look like as a coil. So for that, what we have to do, we have to, like, we have the this one, but what we want our coil will be look like this, and we have created one segment there only, one part. Now what we will do, we will basically just select this one, and directly you can click on that coil, or you can from the history tree also you can select that, and then we have to go to draw option. Okay, just go to draw option. In that draw you will find sweep, and we have two options in the sweep, around axis and along vector. So for this design, what we have to select?
Around axis.
Around axis. We basically want to make this as to work as a circular round. So for that, what we will do, we will click on the around axis. Now it will ask you X, Y, Z value, where you want to make your polygon to be look like a round. So for that, we will select X axis. So just click on the X axis. We want angle of sweep to whole 360 degrees. So we will select the 360 degree and press, and number of segment we will fill as 30. Okay, it will ask you to enter the positive number, so we will write it as a 30, and then press OK. Press Ctrl D to fit your model. Okay, have you created that? Just when it is
Is
over,
there
please.
any there, like why 30 is selected and not more? Is there
Okay,
any?
ma'am, you can select as much as possible, because then it will be looked like a more circular. Now you can see 30 means 1, 2, 3, 4, 5, 6, like that, 15 up, 15 down segments.
So if we select more, is it
So
like
this is
memory will be more
more.
occupied, more analysis, something
Yes,
like
yes,
that?
ma'am. You can consider that also. And sometimes when 2 and 3 coils is there, then we have to more think about this segment part, like how we are selecting that number of segments.
Okay,
Right now, I am basically focused on not on circle. If sometime any other model is required, if some want to design on for other model, they can also go for that by using this.
So then an error is coming. He's saying that fail to sweep the object.
Means first we just have to select that coil. Just click here as a coil, then go to draw.
Okay.
And then click on the sweep, and then around axis. Then select X as a sweep axis and 360-degree and number of segment as a 30.
Sir, I am not able to draw exactly. Can you just tell me?
Okay, I will drawing some other. You just have to change the coordinate. Okay,
Yeah.
like you have from where you are stuck, like
Sir,
from the
yeah, I have drawn a simple this polygon, a hexagonal in my
polygon.
plane.
Polygon
Yeah,
is okay, na?
yeah, yeah.
Just click on the. You have changed the name of the polygon.
एक मिनट sir. Polygon.
Just go to history.
Yeah.
Polygon one name is there. Just you have to click on that and change the name to coil first.
Coil. Yes, sir. Coil one. Only coil.
Yeah, only coil.
Okay, sir.
Just change the name. Press OK.
Yeah, yeah. It is changed.
Okay. Now just go to click on the coil.
Okay.
And then go to this one. This next to project draw. Just click on the draw.
Oh, basically, I just selected the coil. Okay, and then directly I need to go for draw.
That is okay. Yeah.
Draw and then draw.
Then sweep.
Sweep command.
And then around axis will be visible because I have not selected anything. So just coil, draw, sweep. Around axis option will come.
Around axis. Okay, sir.
Now just click on that.
Yeah.
Press Ctrl D.
No, sir. Just this box for the sweep around axis is open. So I need to select the x axis.
Okay, now we have to fit the x
axis. Angle of sweep is 360-degree.
360-degree, full
yeah,
circle.
Yeah.
Then number of segment 30.
Number of segment 30. Then
Press
okay.
OK.
Okay.
Yeah.
ठीक है.
Now press Fit All or Ctrl D.
Yeah.
Okay.
Okay, sir. Okay.
Okay. So now we have to change the material. So how we can do the change the material? Anyone from the participant, if we want to change the material of this coil to copper,
By
how we
clicking
can
on
do
the
that?
coil, sir, by clicking on the coil, we will get the material vacuum, so we can change it to steel or copper, whatever we want. Copper we will select here.
Okay. So same method we have to follow. Just press on the copper, press apply, press OK. Now the material is changed to copper. Okay. Okay, one geometry of the coil is created. Now we have to create a magnet. So for creating a magnet, what we basically required? We have to create a box of magnet. So for creating that magnet, we required a box. So how we can draw the box? We have to go to draw, and there you will find the option box. Okay. So we will set the coordinates x-axis for the as a -3, y as -0.5, and z as -0.5. Press enter. Now we have to set the dx value as 6, tab 1, tab 1. Press enter. Now box is created. Or if you want, you can also create a box and then put the values. Like these are the coordinates. Position -3, -0.5, -0.5. This is the position, starting position. And then the other x size is 6, y is 1, z is 1.
Sir, we need to go for a draw now to create this box.
Yes. Just go to draw, box, just click on the box. And then put create any box and then put these coordinates.
So sorry for disturb, but on my side it's giving
Okay.
errors. It's not moving to sweep.
Sweep, you are not able to do that.
Yes,
Sweep.
yes.
Okay.
May share screen.
Yes, you can
Sir,
do that until
what are the coordinates we
yeah.
need to give? X, Y, and Z?
Uh, for this one box,
Yeah, for
you
box.
can take like I have shared the screen. You just take the snap of that, and then like -3, -0.5, -0.5, and for the X we have to set the value 6 and Y 1 and Z 1.
So
Okay, so please share your
-3, 0.5.
minus 0.5,
It is
minus
minus
1
3.
-0.5,
itself,
yeah,
0.5 and -0.5. Okay.
0.5, yeah,
Yeah.
yes,
Then next is this is a position.
611, 611.
So, for 611, we need to let's say once again enter na this same number
Yes,
6
6, then 1, and then 1.
and 1 1.
Okay, sir, you can share your screen if you are facing problems like
Okay.
creating sweep.
Hello, sir.
So screen is visible.
Yeah, hello. Like I have to stop, I think.
Okay.
Now you can share. Okay,
Sir,
yeah,
what should I
visible.
do to make my property box visible like yours? The property box on your left bottom side. Mine is not showing.
You have
What
to,
should I do?
okay. You just have to go to the view option, and there you have the drop down will come, and there you just have to go to the properties if that is not present.
Perfect.
So just click on that. Okay,
Okay.
you are facing problem. Yes,
So
yes,
here
yes.
I
Do that.
select the
Selected the coil. Yeah.
draw
Then go to draw
on the
around
axis.
axis.
Axis 30.
Yeah.
Then click OK.
30.
Now
Press
it's giving
OK.
error. This one body could not be.
Okay, so
Invalid parameters. It's
I think yeah, some parameter error it is showing. Okay, just redraw this coil. I think. Okay, 1, 2, 3, 4, 5, 6 segment is there. Just open this, create a regular polygon.
I delete this one.
I just delete it and then redesign. Like go to regular polygon. Just place OK. Create a regular polygon. Set the values as 0, 5, 0, 0, 5, 0,
0,
comma 5.
5, 0.
Yeah.
That one. 0.
This one as the 0.5.
0.5, 0.50. Okay.
No, 0.500.
Okay.
Press apply OK.
Same error.
Same error. Okay, that we will like after this session, I will
Okay.
connect
Okay.
with you in team
Okay,
or
sir.
in a desk, and then we will do that. Okay.
Okay. Okay, sir.
So the next, okay. So let me share my screen now. So we have designed this regular polygon and the box is designed. Now we have to change the material and name of the magnet. So just click on the box, name of the box as a magnet, change the material, as NDFE 35 as a magnetic material. Press apply. Okay. So color is changed to this one. Or if you want, you can also double click on that and change the color.
Please tell us the name of the
Excuse me, sir.
materials for the magnet.
What? Material name NDFE35.
NDF35.
Repeat, sir.
Hello.
So she wants to repeat it like once again. Can you show?
Okay. So for that, we just like from the box or
Material
changing of
name,
the
sir.
material. Material name. Okay.
Material
So
name.
you just have to go to this like double click on that magnet, and there you will find the change the name of the box to magnet, and then change the material to NDFE35.
NDF.
Yeah,
Okay, sir.
NDFE 235. Then press apply and then press OK. The next, like we have created the geometry of the coil, we have created the geometry of the magnet, but in our problem, like we can see here, we have the coil, we have the magnet, and we have to provide one excitation in this terminal. So in our circuit also, we have to create terminals, and in this first we have to create the terminals, and then we have to give excitation of the current. So for creating the terminals, we basically have to do like we have to create a section, and after creating this section, we have to do the separate bodies, and then we have to delete one segment and then do the analysis. Okay, so how we can do that? Let me show you. Like first we have to create the section of the coil. So just click on the coil. Just click on the coil and go to modeler. There you will find the surface. Here next to edge you will find the surface, and then go to section, and in that section we have to select the XY. We basically want to cut our coil along XY. So we will select this section plane as XY and press OK. Now two terminal is created. Okay, two terminal is created for you also.
Please repeat the process again that side.
Okay, so first we have to click on the coil, then you have to go to modeler, next you have to go to surface, and then you have to click on the section, and when the section will come you have to press XY and then press OK. Then the terminal is created. Okay, this part is okay, all are in the same page.
Yes, sir.
Now change the name of this coil section. Now change the name of this one coil section to terminal. Terminal. and press OK. And now you can see we have two terminals, but in our problem we only required one terminal to give the excitation of the current, and that current will flow in all the coil. So we have to delete one. Okay, so we have the two, but we basically have to delete one. So for deleting that, the next process what we have to follow, we have to first separate these two. So for that only we have to click on the terminals, like just go to history tree, there you can select the terminal, then go to modeler, then go to boolean, there you will find option like separate bodies. So just click on the separate bodies. Now we have the options like terminal separate one and terminal. We have two terminals separated from each other. Okay, have you reached that point?
Yes, sir.
Okay, so after separation, we basically want to delete. So we will delete that terminal separate one. So for that, we just have to go to click on the terminal separate one, press the right mouse button. Okay, now go to edit. Now you can see the option of delete. So just delete it. Now only terminal is left with us. Okay, all are in the same page.
Yes, sir.
Yeah.
Okay. Okay, so now the next we have to assign current to this terminal which is left to us. So for assigning the excitation, we just have to just click the terminal and go to Maxwell here, or otherwise you can directly go to project manager. There you will find excitation option. Just click on that, press the right mouse button, assign option will come, and then we have to press the current. Now we have to set the value of the current as 100 amps. Click on that, 100 amps. Wire as a solid or stranded wire, so we will select as a stranded wire and then press OK. Or if we want to change the direction, now you can see the direction is downward. If you want, we can also change the direction by clicking on the swipe direction.
So
Okay,
can you repeat this step?
press. We basically have to first go to history tree. In that history tree, click on the terminal. Then we have to go to project manager. There you will find excitation. Press the right mouse button there, assign, and then current option is there. So just we have to click on the current, set the value as 100, then click on the amps, change the wire type to stranded wire. And if your problem say you want to change the direction of the current, excitation current, so you can also swipe direction option is there. So if you click on that, the direction of the current will change. Press OK. Now in the excitation you can see the direction of the current. Okay. Okay, so we will move forward, or if anyone having facing any problem. Am I audible?
Yes, sir. Yes, sir. You can continue. Yes, sir.
Okay. Okay. Okay, so the next we have to give parameters to the box or the magnet. So we have to select the magnet. Directly you can go and click on the magnet, or if you want you can select this by using the history tree. Just click on the magnet, go to parameters, press right mouse button, assign. Here we have to assign torque, so we will select the torque and press OK. Now the parameter torque is assigned. The next step, we basically have to change the angle of the coil. We will basically want to change the angle of the coil up to 45 degree along Z axis. So for that, what we have to do, like the coil and the terminal are the two things, like coil and the terminals are the like we can see. So for that, we basically have to just open this one, current, like terminals and the coil. So for press the control button, select terminal, click on the coil, select both coil and terminal, then go to edit, then go to edit, then go to arrange, and then rotate. And we want to rotation of 45 degree, press OK. Now your coil is rotated 35 degree, 45 degree basically in Z axis. Like, yeah, or if you want able to do that, you can just click on that rotate. There you can see axis and the angle 45.
Sir, please repeat once again. I missed something.
Okay, so just we have to go to history tree. In that history tree, we have to select the coil, press the control button, also select the terminal. So both coil and the terminal will be selected, and then we have to go to edit, and then we have to go to arrange, and then you can see the option rotate. So just click on the rotate. Then we have the Z axis, so just click on the Z if Z is not selected, and then change the angle to 45. Change the angle to 45, then press OK. Okay, all are in the same page.
Yes, sir. Yes, sir.
Okay, so the next step is we basically have to draw a reason for this whole circuit. So let me summarize this, what we have done. We have created a geometry of coil. We have created a magnet box size magnet. We have created the next step. We have created a section in the coil, and then after creating the section in the coil, we have give the angle to the coil. We have changed the material of both the magnet and the coil, like copper and the magnetic material NdFe35. Okay, so these things we have already done, and the next we have to draw the reason. So for the drawing the reason, what step we have to do, how we will proceed? Anyone from the participant?
Yeah, someone answer, please.
There is a rectangular box, red color box. We click on that.
Okay, just we have to click on the rectangle. Then you can see the pad all directions similarly. Here also we will select as a 100%.
100.
Yeah,
And click on
and then press OK. Now for fitting the model in the same page, what control we have to do?
fit all.
Press fit all, or we can directly do the by pressing the Control D.
Then we will select the edges.
For the 2D model, we have to basically assign the boundaries. For the 3D model, it will automatically select Newman boundary condition. So here we will don't have to change that. Okay. Now the next we have to like set the analysis for this. So for the analysis, we will basically go to Maxwell 3D and do the analysis setup option is there, or we can go to project manager. Analysis option is there. Just click the right mouse button, add solution setup, and then we have to set the number of passes as 10 is there. So we can also change this to 15, and then percentage error as a 1%. Then press OK. Now in this setup is ready. Now we have to change the or save our model. So if you run that model without saving, like if you click on the analyze, it will tell you to save the model. So this is the 3D model. Okay, so save that, then it will analyze. It will take some time. Till then, I will also look into your problem, sir. You are facing the problem of regular polygon. Can you please share your screen?
Yes, by the way, it is sorted out. I have closed all the
Oh, okay.
model which earlier open, and then
Okay,
I
okay.
then started and it's working.
Okay, okay. Then it's okay.
Then I will see the
Okay,
video and
so
will complete all the section.
acha. Okay, then it is okay.
Okay.
Okay, so let me reshare my screen.
Sir, please, how do we run? I have forgotten.
What?
Yes, sir. Actually, yeah, I am facing the problem. Let's say for drawing this box.
Okay, just share your screen. So we will look into that. Until then, it will simulate. It will take some 2-3 minutes. So
Okay, I am sharing, sir.
Sir, I want to know how do we conduct the simulation?
just go to analysis. Analysis option is there in the project manager. Just click on that.
Okay.
Analysis, and then press the
Okay.
right mouse button, and then add solution setup option is there.
Okay.
Yeah, sir. Is it visible, sir?
Just give me a second. Yes, it is visible.
Yeah, yeah, sir.
Acha, the coil is created. Okay, you have
Yeah, yeah.
created the coil. The box is not created, na?
Yes, sir. Yes, sir.
See, so you have to create the box, and then you have to create the other. Okay, so okay, sir. Then just select the box.
So also let me know how to create a section. It's not visible there, I think. It will also help me.
No, 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 no. First, we will create a. First, we will basically create a box, and then we will
Draw a
create the
box.
section in this.
Draw a box.
Yeah.
So
Just yes, yes. We have to put the x-axis below the x-axis. Just select the box.
sir, 1 minute. Draw a box.
Box.
I think speed is
and
16 is
put the values of
the speed
just
is quite slow, sir. Actually, yeah. Tell me, sir. X value
mhm. X value, you just write it 1 second. X value -3,
-3
tab
-3 tab
first, -3 tab -0.5,
-0.5
tab -0.5,
-0.5. Okay.
press enter.
Yes.
Now
Enter.
I think enter is not selected and the value. Press enter. Now enter the value 6. X is 6.
6.
Tab 1.
1.
Z 1.
1. Right. Enter.
Press enter. Your
Okay.
box is outside. Okay, not to worry. Just open that box. From the history tree, just open the box. Double click on that
Yeah.
box 1.
Yeah.
Here, okay, no, create box. Just double click on the create box. Just change the name here. Name of the box change to magnet.
Magnet.
And change the material
Material.
to NDFE 35.
And B
NDFE
FE 35.
35. Yes.
Okay, sir. And okay.
Now
Apply.
press OK. Apply OK. Okay.
Yeah.
Then click on the create box next to magnet.
Create
Below the
box.
magnet,
Yeah.
create
Yeah.
box.
Yeah.
Yes. Just double click on that.
Yeah.
Now we have to set the position as -3, x -3,
-3.
comma
Yeah.
-0.5,
-0.5.
comma -0.5, same -0.5.
-0.5.
0.5. Yeah.
Okay, sir. And
Yeah. Apply. Okay.
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 Yeah.
Okay. Now you have to create section for that, and the same process like section, create a section for the coil you have to do. So I think my simulation is completed. So let me show
Okay.
them the result of the torque, and then we will take a break of 5 minutes, and then we will come for the next simulation.
So
Okay, so let me share the screen.
Mugdha
Yes, ma'am.
ma'am is having a so like difficulty in deleting one of the terminal. First, you did some separation, and after that, we have to do it step by step. So, is there any
Okay,
steps
so
which is given some article or somewhere they can refer it?
that I will basically I will write that all the step and share.
Okay. Yeah.
Then
Anyway,
that
we
will
will
be
be
okay for
sharing this recording also, so they will be able to see that.
that is the good. Yes,
Mugdha is
yes,
also
yes.
there, but anyway, she was just she got stuck. That's
Or if they will face any problem, they can write to me.
all.
So the only thing is that ki how to delete one terminal. Actually, I have divided the coil
Okay,
into
okay,
two
okay. So
sections.
okay, just look at my screen. So let me share my screen.
Yeah, sir. After creating this box, na, so you just tell me. But I think this the next step is to we just need to divide this coil into the number of section.
Okay, just we have to click on the coil. Now my screen is visible.
Yeah.
Yeah.
Okay.
That is click on
So
the coil, then I think
yeah.
draw and then sweep. Right, sir?
No, that is for the creating
Section.
the whole coil.
Yeah.
Now we are basically interested in creating section.
Yes,
So
yes.
for that, just we have to click on the coil, then go to modeler, and there you will find the option surface, and in that surface you will find the option as a section. Just click on the section. Now we have to create the section. Press OK for that. Section XY.
Sir, we need to click on double click now on the coil.
No, just single click.
Okay.
And then go to modeler. Next to draw, you will find the modeler. Just click on that.
Yeah.
Drop down will come. There you will find surface.
Surface. Yeah.
There you will find section. Just click on the section.
Okay.
Select XY.
Yeah.
Press OK.
Okay.
Now the section is created.
Yeah.
Okay, so but the two section is created. So now we basically interested in separating these two terminal. First, change the name. Change of the resulting sheet to terminal. Change the name. Double click on that.
Double click on, sir, section from.
Yes.
Section from, double click.
No, the name. That name we basically want to change to the terminal. Just click on that and change the name to terminal.
No, it is showing, sir, that in the coil section 1, it is showing the section from. So in the section
Okay,
from,
so
this is
just
a
share
coil
your
is showing.
screen. Just share your screen.
1 minute, sir. Yeah, is it visible, sir?
No. Okay. Yeah. It is coming.
Yeah.
Yeah, you have created the section. Okay, coil section 1. Just double click on that.
Yeah.
Change the name to terminal.
Name terminal.
Yeah, press OK.
Yeah.
Now terminal is already clicked. Okay, or otherwise if somebody has not clicked on the terminal, just we have to select the terminal in the history tree, then go to modeler. Just go to modeler.
Yeah.
Go to boolean. Next to surface, go to boolean. Separate bodies.
Yeah.
Separate bodies.
Yeah.
Now the terminal and the terminal separate one will be created. So we have to delete the extra. So we will delete that terminal separate one. So that terminal separate one is already selected.
Yeah.
So press the right mouse button
Right
at the
mouse
terminal
button.
separate one. At the terminal separate one.
Yeah.
There you will find edit option.
Yeah.
Go to edit.
Yeah, edit.
In that edit you will find the delete.
Yes.
Just delete it.
Okay.
Okay, now only terminal is left.
Yeah. And after then, sir?
We have to analyze.
Okay. So
no, the next step is to provide excitation. To the coil.
Yeah, excitation.
Yes.
So yeah, this is the excitation. Current one.
So Mugdha ma'am, your query is solved by this?
Yeah, sir. Can I share my screen, sir?
Yes. Ajay, I think you have to stop share.
Yes, 1 minute.
Can you see my screen, sir?
Only half, I think. Why not full?
This one is the model, sir.
Okay, just wait. Yeah, you have created the two terminals, na? Terminal.
Yes, sir. So after clicking on this terminal, we have to go on this modular, then
separate bodies. Go to Boolean.
Boolean, then
Yeah, separate
separate
bodies.
bodies.
Yeah, now
After
separate
this,
body
I
is
have to
created. Just
delete
press
this
the right
option.
mouse. Yes,
Delete
then go to
this.
edit,
Delete.
delete.
Yes, sir.
Okay,
Okay.
only one terminal is left.
Yes, sir. Now I have to give the
Give
excitation from
excitation.
here.
Yeah, yeah. Just selected. The terminal is already selected. Just click on that terminal.
Terminal. Okay, sir.
Okay, and then go to excitation in the project manager window.
It is showing in the excitation.
Press
Or
the
current one. Current one is showing.
current one, means you have already given the excitation to that.
No,
So
no, sir.
just
I have not. I have not given, sir.
now just click on the excite. Just done. Press the right mouse button at excitation.
Okay.
Then
Yes.
assign excitation as the current.
Yeah.
Yeah, value 100
10
amps.
100 amp.
100. Yeah. Wire as a stranded wire.
Sir, my one error is showing, sir. Excitation current to assignment must contain exactly one selection or to be connected edges. It is showing the message.
Yes, I think because you are assigning the same and same excitation one by one, that's why. Just click on the excitation.
Yeah.
In the project 4, I think just drop down that.
Project 1 or?
Yeah, no, yeah, current is already assigned.
Standard
Which
value?
system yeah, yes. Press OK.
Okay, fine, sir.
Okay, share your screen, sir.
Yeah, 1 minute, sir.
Thank you, sir.
Is it visible, sir?
Yeah.
Yeah.
Current is already, just click on the current.
Yeah.
Oh, just give me a 5 minute, I will reconnect. Okay.
Okay, sir. Okay,
So we
sir.
will take a break of 5 minutes and then connect.
Okay, sir.
The participants, you can also take a break of 5 minutes and then we will join. Don't get disconnected, be here itself.
It is crossing the
Okay.
body of magnet. That's why you are getting
Okay.
this.
Okay. So I think it is
If we,
touching internally, yeah, this box and
yes,
this
yes, yes,
coil.
yeah. So that's why you are getting the internal
So, sir,
error.
can
So otherwise,
at this time, at this stage, can we change the
yes,
dimension?
yes, yes, yes.
So
We
how
can
can we
change
get?
by
How can
just
we can do
create
it?
regular.
One
Just
minute,
go
sir.
to create.
Go to create.
Yeah,
Draw means
create regular.
draw.
No, 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 not draw. You have
Okay.
already drawn. Just open
Okay.
that.
Okay. So create.
Yes, create regular polygon option is there.
Uh,
In next to coil, below the coil.
Below the coil, it's a create regular.
Yeah,
Yeah.
yes, yes,
Yeah.
yes. Just double
Then
click on that
yeah.
and set the center position or the coordinate like we have set.
Uh,
Uh,
what is the
just
value then?
anyone having the value.
Center position is
Okay, just let me check
yeah.
with my model and then I will. Okay, so you can set the value as center point 050, comma 5, comma
Uh,
0,
0, uh,
comma 5.
comma 5,
Yeah, 0. Okay,
0.
then go
Okay.
to next.
Start
Start
position.
position.
Yeah.
In that first one, 0 0.5,
0.5, comma
0,
0.
and then next is also 0, comma 0, and
Okay.
delete others.
Yeah.
Then change the number of segments 6 to 12.
12.
1, 2. Yeah,
Okay.
press apply. Okay.
Apply and okay.
Press OK. Oh,
Control D.
some problem. Just open that regular polygon.
Yeah, sir. 0.
5 mm, that is also okay. Starting position 0.5, 0, 0. It's the same value I have also put. Okay, just next start position 0.5, 5 and 0.
0.5, 5 and
5
0.
and 0.
5, okay.
Now it is okay. Now
So
you simulate. Yeah, now
simulate
yeah.
analysis, no?
Yes.
Analysis and then
No, no,
setup.
setup. Just
Okay.
run the setup.
Yeah,
Just
setup
right
one.
click. Yes.
Setup
Right click and analyze.
analysis.
Okay, so it will take some time to simulate. Okay, anyone facing other problems? So we will also look into that.
Can I share my screen, sir?
Yes, yes. Just share, sir. Ajay, sir, please stop
Yeah.
sharing.
So can you see my screen? So this
Yes.
error is coming. Internal error and simulation completed with execution error on server.
Yeah, same error, sir. I am also receiving in my screen.
Okay. Okay, just do one thing. Like we have the recording, and
Okay.
you practice that, and we will meet tomorrow, and we will resolve that.
So I think on student version it is not like showing result.
No,
If anyone
no,
is
no, no. It
getting
will
result.
show result.
So I am getting a result.
So just follow the process. that by using
Maybe
this
some
link.
small setting error or something will
Yes,
be
yes,
right.
some setting will
So we
miss.
will try
So
to
that.
share you this recording so you can go through
Mhm.
and you can try it. So that's a better version, and by practice we
Yeah.
can do more. And many
And
people are
then.
mainly the like system error. Many are saying they couldn't install it. Many like since the software is little high end also, so that's also a problem. And
Mhm.
those who are having 64-bit also, some were not able to install. So such problems are also there. Tomorrow, I
Okay.
think we can go directly. Like after clearing their doubts, we can go to the EV. Like you will be just showing us how to connect this.
Directly, like this is the only design and development, and
Yeah. So
tomorrow
I
we will
think
go
same
for
procedure
final.
goes for all.
Yes, yes, yes.
Yeah.
This is the same process for the other. Like if you are select ED current, the same process we have to follow for the ED current. So this is the only solver, and then doing the process. Now we will basically do the like how we can go for EV design and development. That I will show you tomorrow.
Yeah. Okay, sir. So participants, you can now we like 4 o'clock and we will stop with this. You have the software and others also, like mainly the requirement is 64-bit. You can do it. Say with 64, I also first initially I was thinking, oh, it's not installing, but it got installed. So if you have any problem, just check with and you can just contact sir also, Kartikesh sir, for the installation. But I don't think so there'll be any problem. We have to give proper path, and when you're downloading a zip file will come, keep the zip file in one location, and from that location itself setup you have to run. So that's the only thing. Today's session video, yeah, surely we will give you the recordings. Okay, all recordings will be sent to you, so no problem, you can practice it. And tomorrow mainly we will be going into the EV portion. Now you have got an idea of how the software looks and what are the procedures. It's not so tough, so we have to just look into the like different aspect for electric vehicles. So tomorrow I think we will go into electric vehicle section as such, and we will start working on it. Thank you, sir. Thank you, Kartikesh sir, for spending your time with us and clearly
Thank you,
explaining
ma'am.
step by step to all our participants. And once again, I thank you. And tomorrow, sharp 9:30, we will meet, sir.
Okay, ma'am. Thank you all, and we will
Thank
meet
you, sir.
tomorrow.
Yes, sir. Thank you, sir.